Hello. I am back, finally, for more Advent of Code. And we left off on day 20. Part 2, because part 1 was solved. So today we will have to catch up. The last day of Advent of Code is today. I think it's only 25, right? So 5.5 is what we need to do. I do remember this that we were solving here, right? Is it still saved for me? We were visualizing this graph. Graph is online. Yeah, I was here. All right, let me go open my code again. Why is this menu all visible again? This is wrong. Menu at the top is not supposed to be here. Show editor, context, menu, toggle menu bar. Oh, there you go. Maybe I just clicked on it last time. Okay, here we go. Here's our graph. I make it go here, right? And we can see what it is. So we wanted to like figure out when does the Rx node receives a low pulse here, and we can see that before the Rx we have HP with 4 inputs, and the broadcaster has 4 outputs. And I am pretty sure here that every output is connected to 1 input. That's it. So those are the subgraphs basically that we need to extract, and those will be like doing the high pulses in a loop here, right? And let me remind myself, I need to find the fewest number of button presses required to deliver a single low pulse to the module named RX. Hello, Pog7. Yeah, so in order to get the low pulse on the RX, we need for the conjunction to send the low pulse. Let me just remind myself of the stuff. Low pulse. Conjunction sends low pulse when everything is high, basically. Otherwise, it's a high. Right? So I want to know when all of the inputs of the HP are high pulses. Right? And about the other parts, I don't really care about, even although this is also a pretty specific structure, it seems. But I'll not care about that too much, because I'm pretty sure that all we really care about is the fact that there is like about 10-15 flip-flops in every single subgraph here, which means that it's going to loop in less than 2 to the power of 15. So yeah, we just going to figure out how often do the high pulses are being sent to the HP inputs here on every single input. And I imagine it's going to be 1 high pulse every certain period. But let's start working on this. Let's start working on this. This is our previous part 1 code, and we also were trying to see if we had loops, and we did have loops, so this can be deleted. This is part 2 basically, which we can redo completely, right? We were trying to do the brute force solution, which probably obviously doesn't work. So here, this is the important one, the HP, right? Final conjunction is HP. All right, let me make sure, assert that module, assert that we match the modules, the final conjunction module is the conjunction, right? Like this. All right, and then we also assert that this module, the final conjunction, outputs is the Rx, right? Like this. Other things are unnecessary. Okay. Cargo run. Merry Christmas. Merry Christmas, everyone, indeed. Yeah. Although I personally don't celebrate it because we don't do it in our country. But for those who do, Merry Christmas. Press button. Half is unused. Wait, what? Press button. I think I changed it and then I never got back for the part 1 to work. Let me do part 1. Yeah, it's 0 and 0 because this is not called. So whenever we have a pulse here, we say av name and pulse, right? This is what I wanted to do. Every year I feel like I'm missing out by not doing an event of code, but I always have a side project I'd rather work on. So you watch other people do the challenges. I might not do it next time either, because it takes a while and I would rather continue working on my game. But we finish this. It's okay. And then we come back to the link cider. Yeah, but I should work on my personal projects too. Other than Advent of Code. It's nice to have something like this once in a while, though. We'll see what if I want to do it next year or not. This is the first time I actually did Advent of Code anyway. On the previous years. Can I see the previous year's events? Yeah, I just had 12 stars on 2021, and that's it. So I thought I should at least make it to the end at least once. Okay, this works. This works. Let me remove the printing. Go parse 2. All right, good. So this asserts hold. All right. Press the button. I want to press the button a little differently here. I want to press the button a little differently here. Specifically, I want to instead simulate by sending a pulse to the node of this name. We send there this pulse, you know, and then we simulate it. So node, and now where from, where to, what pulse? Yeah, so instead of button into broadcaster, I'll say from node and pulse over here. So for the part 1, we are basically going to send the pulse from the button into the broadcaster with we are sending the low pulse. Okay. So there you go. Here's what we are going to do here instead. Here's what I'm going to do here instead. The screen shake effect would ruin me. You are here. Are you here for the first time? Did you? It's so subtle. I'm wondering how you notice this. I don't even see it anymore. You know, I'm so used to it. I don't even see the screen shake. All right. I need to basically. I will just use the same simulation, but instead of simulating from the button to the broadcaster, I will simulate the separate parts of the broadcaster separately. Okay. So I do something like for output in modules broadcaster outputs. I'm just going to clone them so that I don't have issue with borrow checker here. Output is what we have, so we're going to simulate a bunch of times from the broadcaster. I'm sending a pulse into the output, and I'm sending the low pulse, so basically skip the button and do the broadcaster, right? Modules, and whenever we have a pulse, right? Whenever we have a pulse, I am going to store it basically I'm going to store the pulses that I get, right? Rx is receiving a pulse basically. Rx input pulses is going to be a vec that I have here. So I'm doing Rx input pulses push pulse, right? Does that make sense? Oh, I do this only if we receive a pulse in the Rx, obviously. Wait, hold on. Not Rx, the HP, right? HP is the important one. HP is the important one. Okay, so I simulate by pressing a button, and then I simulate it again, and then I simulate it again, until we actually figured out that we are in a loop, okay? So for that reason, I need to know what's my current state, what my current state is, right? Modules. Yeah. Since I'm compatible to static str, views matched, we'll use lookup table. Instead of a conditional branch. This is not a static string that I have inside there, it's an arc string. What happens if you can't complete? This is my first participation. Nothing happens. I'm pretty sure nothing happens if you do complete too. It's just something that you do for fun. You know, if you want to, you complete. If you don't, then you don't complete. Wait, what are you saying? Since you're comparing to a static string over here, is that what you're saying? We'll use a lookup table instead of a conditional branch. Ah, if I needed to compare with multiple other strings, then it would make sense to use a match, and it would do it better. But for just one condition, it doesn't matter, because I'm just filtering out those that are HPs here. Okay, so I'm going to simulate this in a loop, and basically I'm going to stop in case I already know what's going to happen next, because we are going to be in a loop. So visited means that we already been there, you know, been there. Let's make this a hash set. And I'm just going to say while being there, I'm trying to insert my current state. My current state is the entirety of my modules, technically. So can I just do this? This is a little bit too much information to store in a hash set, but I think it's okay. So insert will return a boolean if the set did not contain the value, true is returned. So yeah. This will return false once we are inside a loop. Now I just need to make sure that I can clone these guys and hash them. You know? Hash map is not hashable though. I think I will have to use a binary tree map for that, right? because the hashes, they have random order. So the modules are also going to be a binary tree map instead, which is alright. Simulate, this needs to be a binary tree map. And then this is mutable. Okay. So basically, yeah, let me make sure that I clone everything. Let's mute modules is modules clone, because I reset to the original state, and from the very beginning I see what are my HP input pulses, right? So after everyone, I'm going to say print out the being their length, which is basically the length of our loop. And also I want to know what are the HP input pulses. And I'm pretty sure that there's going to be only one high pulse. Maybe, you know what, maybe I only want the high pulses. You know, let's do the high pulses. High pulses, push the current like loop, like the current tick, you know, we just do tick plus equal 1 here. So we push the tick, if name is HP and pulse is the high pulse, right? We want high pulses on the HP. All of these will be high so that RX receives low. Yes. There you go. Let's see. This is the first part of it. Okay, there you go. So we have 4 parts, right? We have 4 parts of 4 subgraphs, right? And every one has a different like looping length, and we basically receive a high pulse only. Well, it looks like we're receiving the high pulse not in the very end though. But close to it. Wait, this is in the very... Oh, I mean... maybe tick is like the number of button presses, right? So this is already 1 press when I'm simulating, right? This is button presses, basically, right? So we need to press the button 3967 times to get a high pulse, and we press it 1 more time, and we are inside a loop after that, basically. Right? So it is in the end of the loop. And from here, it's basically the same as some other day when we were doing the loops. Let me find the previous day when we were doing the similar thing. Anyone remembers what was it? Day 10? Day 9? Day 8? Yeah, day 8. We had the cycles. And I wanted to merge two things. I'm just going to copy paste this. I'm just going to copy paste this. Copy pasted from day 8. Is Lua a good language to learn if you want to learn game making? I never made games in Lua. I don't know. Why don't you learn Godot instead? And Godot script, which is Python. Because if you want to make a game, it's not about a language, it's about the engine usually. So I think Godot is a good thing to get started with. Even although I barely tried it myself. This requires an LCM, by the way. LCM. Okay. And I've copy pasta. Merry Christmas. Merry Christmas to you too. Okay, so here's what we have. Originally, we have all high pulses. All highs is valid steps where we start at 0 with period of 1, right? And then for every single input, basically, right, I assert high pulse is HP high pulses. I'm going to try and convert this into no 0. I'm just going to assert that the HP high pulses length is 1, right? So we have this high pulse, and I want to merge the previous all highs with another input, which is going to be the period is going to be the length, so been there length, right? And the start is going to be the high pulse. Is that right? And this is the new all highs. So now we basically are going to have all high pulses to the HP on a new period that we have calculated, and we will say that answer is whenever we receive all the high pulses for the first time, so the start, right? And then this is what we print out. Okay, let's do the example. No entry found for a key. Oh wait, hold on, we don't have it in the example. We don't have an example, so I will just have to I'll have to believe that I done it properly here. We have some sort of an answer, and let's see if it is correct or not. Day 20, part 2. Submit. It's not the right answer. Your answer is too low. They help me by saying if my answer is too low or too high. Valid steps does not need to be mutable. Yes. Too low. I think it should be like +1 because I think I want to subtract 1 here, and then because this is the number of this is the number of button presses, but I wanted to like do the steps instead. Or I should start with 1 instead, maybe. Let me see. 5, 1 something, 63. This is still the same, even although I started with 1, because this is the same. Okay. Hold on. Hmm. So let's make sure that it is exactly what it is, right? So let me do this again. I'm going to do one more time. 0 to bin there length, because this is the loop, right? I'm going to simulate again. I'm going to simulate again and make sure over here I'm going to assert that the number of button presses is equal to the previous high pulse plus the length of the loop, right? No more pushing. But it was not. Okay, hold on. This is weird. So I just repeated the same loop, and I'm off by 1. I have an off by 1 error. Hold on. So it means that the loop length is not this. Is it this minus 1? No, it is this plus 1. Hold on, what? No. How can this be, though? How can it be like that? How can it be like that? Because we literally just check the entire state of the graph, right? And that's our state, and we are going in a loop, saving all the nodes that we have visited, basically. So the length of the loop is the length of the nodes. But I'm off by 1 over here when I'm checking myself. High pulse, untrust range exclusive by default. The left one is inclusive. Like if you use the double dot, the right end is going to be exclusive, yes. But it doesn't matter. Like right now I'm panicking even if this is an infinite loop. It does not matter. For inclusive loops you can do dot dot equal, by the way. That's not the problem though, because I'm panicking because I'm checking thing. It doesn't matter. I'm just making sure that I'm not running this infinitely here by doing only one more loop. Does it has anything to do with the loop length? So hold on. So I press the button. Let's say that we Off by 1. How can this be? Hold on. The right one is actually... Hold on. The right one is an odd number. The number of button presses that I need to have should be... What's my loop length? Let me see. My loop length is an even number. Yes. I guess I can assert that the button presses is equal to the loop length, because that's the other thing, right? Yes, like that, and that is the same thing right here. My loop length is going to be -1. No, the... Why? It's the number of button presses that gets me back to the original state. Oh, wait, hold on. The loop length. I know why. I know why. Because we are looping not to the very beginning of the loop. It's one more time. It's similar to... it is similar to the other task, right? So basically, we have a graph which from this state goes to this state, goes to some other state, goes to some other state. It is not guaranteed then that we go to the beginning of the loop, to the very beginning. Our loop can look like this, you know, and this probably is what it actually looks like. So the very first state is going to be skipped, I think. So being there is not a hash set; it's going to be a hash map for the number of button presses it took me to get to this state, and the loop length is basically the difference, which is going to be this -1, obviously, but still. So I've been there. I insert into the modules the okay, I'm going to loop instead, and then I say that if let some previous value is been there, insert into the modules the number of button presses, then it means that I am inside the loop, okay? And this is loop length. This is loop length. And the start. Previous. I just want to know the button presses minus previous, and this is the loop length basically. Right? And then we do that, and this should now hold the assertion. Yeah, okay, the assertion is now correct. The assertion is now correct, but then the all highs, I want to start on the high pulse, and we're looping on the loop length. Shit. Hold on, give me a second. I need to take a bathroom break. We're almost done here. All right, I'm back. So what we have here, I'm pretty sure is not the correct answer. Try again. Oh, please wait 1 minute before trying again. Okay, sure. But this is not the correct one. Oh, wait, it is the correct one? Okay, easy clap. Easy clap. Alright, well, we're done with this problem then. I'm not even going to think about it. This problem is a little bit annoying. I think this one was the hardest day so far. I'm not sure. We have 5 days left if there's anything harder than this one. But yeah, this one is annoying. Because you need to like see what the graph looks like and shit. Alright, day 20. Commit push. Alright. I'm just happy that I can close this finally. Alright. Let's start on the day 21. Let's start on the day 21. Oh, day 21, the step counter. You managed to catch the airship right as it's dropping someone else off their all expenses paid trip to the desert island. It even helpfully drops you off near the gardener and his massive farm. You got the sand flowing again, great work. Now we just need to wait until we have enough sand to filter the water for Snow Island and we'll have snow again in no time. While you wait, one of the elves that works with the gardener heard how good you are at solving problems and would like your help. He needs to get his steps in for the day and he'd like to know which garden plots he can reach with exactly his remaining 64 steps. He gives you an up-to-date map of his starting position as and garden plots dot and the rocks. For example, this. The elf starts at the starting position, which also counts as garden plot. Then he can take one step north, south, east, west, but also only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. And takes the second step. Alright, after 2 steps, third step. He will continue like this until his steps for the day have been exhausted. After a total of 6 steps, he would reach any of the garden blocks marked this. In this example, if the elf's goal was to get exactly 6 more steps today, he could use them to reach any of the 16 garden plots. However, the elf actually needs to get 64 steps today, and the map he's handed you is much larger than the example map, starting from the garden plot marked as on your map. How many garden plots could elf reach in exactly 64 steps? Okay, so it seems like this one is pretty easy. We just do a like breadth first search from the starting position, see how many spots we can reach in less than or equal to 64 steps, right? In less than or equal than 64 steps, and then we can reach every single cell in which we have been in an even number of steps in exactly 64 steps, because we can like just be going backwards and forward. So like 1 backward and 1 forward means basically minus plus 2 steps, right? So for that reason, we have a checkerboard pattern like this, covering the everything that is reachable in less than or equal to 64 steps. And that's it. Okay. This one is much easier, at least the first part. Let's start. Let's start, and then the example. The example is this. Okay. So let's read the input first. The map is going to be input lines So the map is going to be a double array of the tile, where tile is either garden or rock, right? And also I need to figure out where the start is, right? So the lines, for every single line, I take the characters of the line and I'm going to match the character here. And if it is a dot, then we have the garden tile. If we have a hash, then it is a rock. If it is an S, then it is also a garden. But in addition to this tile being a garden, I mark the start with the current position. You know? So start is row and column. And I assert that the previous value was none, because we only need to have one start. Right? Okay, so then we assert that we have found the start. Start is start unwrap, and this is us reading the input basically. Day 21, part 1, example. Let's go. Not the example also. Okay. Okay, we have the start, and now all I need to do is to do a BFS. We do have the pathfinding crate, even although I can write the BFS myself. Let's do the graph directed BFS. Let me see. Start, successors, and success. Wait, hold on. This does not give me the distance to the nodes that I am visiting, it seems. It gives me the... There's a BFS loop. Shortest loop from start to start if it exists. BFS reach. Maybe BFS reach is what I want. Start successors. We have BFS reachable, where we just reach the nodes though. No. Okay. You can walk on the Scribble Square too, as long as you take a step. Yeah, I know. I was just explaining my solution. I need to find everything that's reachable in less than or equal to 64 steps, and then out of those, every step that is an even number is reachable in exactly 64, because that's how it works. So like including the original one. Okay, fine. Let me just write my BFS myself, sure, because I don't see the API in the pathfinding crate that I can use. Okay. So we have a queue. We have a queue, which we start from the start, right? We start from the start. We also have the distances. The distances is going to be a hash map from position into a distance. And originally it's going to be for the start position. The distance is 0. All right. Now we do a while. We have some node, some x and y in the queue for front. We figure out all the next steps that we can do, right? But we only go outwards, we don't go backwards when we're doing the BFS here. So we do for direction in the directions that we can have is -1 0 1 0 0 1 0 -1, right? So new x is x plus dx, new y is y plus dy. This is u size. I think I want the row and column to be integers here. Okay. So then I have found the thing that I can go and if the distance is not calculated there, so if distance entry for the new x and new y I'm going to match on this entry, and if it is vacant, which is empty, actually, you know what, let me do an if let here. So yeah, if it's if it is empty, then I insert the new distance, which is going to be distance from my previous position plus 1, right? And I also push this node into the queue. Push back, new x, new y. Groovy boy. Hello. No Factorio today. I need to catch up with the advent of code. We'll see. If I solve the remaining 5 days quickly, then I maybe play Factorio today too. But I need to. I have missed a little bit of the advent of coding. Need to catch up. Okay, so this is basically my BFS. All right, I know the distance from the start for every single plot. The only thing is I need to make sure that that it is something that is actually reachable. So if map get this some tile, we need to figure out that we are inside the map still. Right? So if we are outside of the map, then we ignore that movement. And also, if tile is a rock, then we also ignore, because we cannot go onto a rock. Okay? And that's it. That's it. Distance still needs... Okay. This distance is from the position, which is that, into an actual distance, which is going to be whatever. This is the distance, U64, U32. All right. Distance entry. This must be mutable. Can it borrow distance as a mutable, because it's also borrowed as mutable. Over here. Yeah. So this is the current distance that I need to calculate originally. It seems. You want to make time to play Factorio someday? Yeah, Factorio requires a bit of time. In case you're interested, we are playing the Death World Marathon on my other Twitch channel, the Kobe Boy. All right. Playing Death World Marathon with 600% biters. Vacant entry. Insert. Okay, this does not need to be mutable. I cannot you tap that? I have no idea. Oh, you cannot click on the name? Weird. Which is weird. Sometimes. Okay, we did our breadth of trust. We marked everything that's reachable. So now let's go over everything that's reachable basically for distance in distances values. I only care about the values. So if distance is less than or equal to 64 and distance is an even number, then it is reachable in exactly 64 steps. That's the thing. So I just add answer plus equal 1. And this is our answer for the part 1. Should be good. So for the example, it is 42. It's not 42, it is 16. Oh, wait. For the example, it is 6 steps. For example, they want me to do 6 steps. So let's check that for the 6 steps, it would be 16. Yes. Okay. So now we can change this back to be in 64 and run this on the actual input. And this is our actual answer. This is the right answer. Continue to part 2. The elf seems confused by your answer until he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and perfect cubes, not his step counter. The actual number of steps he needs to get today is exactly this. But it doesn't matter. Oh wait, hold on. He also points out that the garden plots and rocks are set up so that the map repeats infinitely in every direction. Oh shit, wait, what? Now that changes everything. So if you were to look one additional map width or map height out of the edge of the example map above, you would find that it keeps repeating. I also see, hold on, so in the example, the edge of every single part of the map is a garden, it seems, right? Okay. Okay, the map repeating infinitely is the thing that we need to think about. Let's take a look at our actual input. And it looks like on the actual input also the first line is all dots. And all the right edge is also all dots. So that makes... so like because of that, because of that, basically, because of that, in order to reach the repeated map that's like top right, I can just go always from this one. I don't need to enter anything else, is what it means. Hello. I'm doing okay. I'm doing Advent of Code currently. Day 21, part 2. Is that the intersection planes thing? This over here is the garden plots thing that are repeated infinitely, and we need to do an exact number of steps. If you did this one. So the first part was really easy, but the second one, I'm still thinking about it. Because I cannot just repeat the map and go this many steps to the right. Can I? I mean, maybe I can. It depends on the input, actually. What happens if I just make the map go infinite? Like, actually. Like, actually. If current distance is more than or equal than max distance, continue. And then max distance is going to be, if we're doing part 1, then it's 64, right? But if we're doing part 2, then it is this many. Okay. And then the tile that we're doing, so we are not going to skip negative ones. And I'm not going to skip the positive ones. All right, let me do this. Or x is more than map length. Or y is more than or equal than map 0 length. But I only do that if part 1. Only then I check for out of boundaries. Otherwise, I do the rem Euclid by the map length here, right? Which is always going to be there. So this is the x, the row, and the column is going to be that. Right? Rem by map 0 length. Okay, but the tile needs to be copy. All right. So this will make me go infinitely. I just stop doing the BFS if I am too far away. I'm pretty sure this is not going to work really well. It's going to be pretty slow here because this is in one direction basically. So it's basically this number squared is the number of tiles that we need to actually visit. Part 2. Part 2 example. Part 2 example. And also, hold on. Example. Let me do the max distance. If example for the part 2, for the example, I want to do, let's do 5,000 steps. No, I don't want that. Part 2. If I have a comment, then Clippy does not warn me. That's nice. Okay, 5,000 is also still too much. Wait, hold on. Am I running correctly? Let me do 6. Here. 6 is 16. Okay. 6 is 16. And then 10 is 50, right? 1,000. 1,000 is still running. 668697. Okay. So the solution is correct. It's just very slow. We need to improve it. How old are you, by the way? I'm 30 years old. Okay. All right. Do you have imposter syndrome? Self-doubt in intellect, skills, or accomplishment among high-achieving individuals. Self-doubt? Well, we do doubt ourselves sometimes, yes. I thought it's a normal thing to doubt yourself sometimes. All right. Here's what I'm going to do then. Here's what I'm going to do then. Here's what I'm going to do then. The actual maximum distance that I'm going to do is map length let's do max BFS distance is going to be so basically I just want to calculate a couple of repeated maps around me. Okay, that's what I'm going to do. That's what I'm going to do. So map length, maximum of that, and map 0 length. How goes the venting? It's okay. 21 is the day that I'm doing right now. How's your Kattenberg that you are back to, right? This is the last day of the Advent of Code. And hopefully after that we can return to the Linksider Brainoid. There has been some work done by Davey there, and I did not check it out yet. And we will need to work on the audio stuff that we talked about too. Because programming, math, physics, etc. is a way harder than it was yesterday every day. Because we need to improve constantly, and the medical doctors don't need to improve constantly? Is that what you're saying? I think... Well, I think it's like a lot harder for the doctors to like do the research themselves, but programmers, they can. For doctors, it's much harder. So they have to just stick with what other people have learned, I think, might be the thing. Right? You cannot experiment on people as a doctor, but we can experiment on our code. Max BFS distance is this. So let's say that the map size multiplied by 4. Multiplied by 5. There you go. Map size multiplied by 5. Let's do the actual one. Okay, so it runs for a little bit of time, right? And we basically calculate the BFS for everything. So now I'm going to just see that I'm just going to see that here's our original map, right? This is the center basically, and then I want to make sure that if we go, like, for example, diagonally, then the distance on this position is equal to the distance on this position plus a constant, which is the same constant when we go this direction again, basically. Hello, Java. And then similarly, when we're going just right, it's probably the same. When we're going just up, it's probably the same. And have I ever tried building a game and releasing it? Well, I am trying to do that, like, right now. I mean, right now I'm doing Advent of Code, but we have a long-term project, which is the Linksider. This was originally made for the Game Jam, and we're making it into a full game. Hopefully we release it next year. Yeah, we just keep on doing some random things that are not working on that game, but there has been a lot of stuff that we did for that after the Game Jam. Okay, anyway, this is the plan that I'm going to do right now. Why wait until 30 to start making a game? No, I was making games for a long time, but I never released a game. I was doing it as a hobby, like, that's it. That's it. Why? Because I have other things to do? Making a game means that, like, can I guarantee that I will earn a lot of money by making and releasing a game? I don't think I can. So I was just working on other things, doing actual work, getting some money, you know? Now I can afford a little bit of no work to try and release my own game, I guess. Yeah, I mean, our project is not that big. If I was not like doing Advent of Code, if I was not doing more game jams, then I would probably have more work done on the game by now. But at the same time, if I was not doing game jams, then I would not have the game idea that we try to make into a full game. And by doing game jams, by doing a lot of small games instead, we have figured out what, like, I mean, the Linksider is a pretty good game, basically, is what I'm saying. I'm pretty sure. So if someone fund you, you would full-time make a game. Yeah, sure, but I still want to do streaming other things too. But I mean, yeah, if someone would fund me, sure, I think. Although I kind of want to do it, try to be released by myself anyway. Like, I don't know. Funding would be nice so that I don't have to like eventually I will run out of money and I will need to do like more work, right? But yeah. Please tell me you are a billionaire and we can apply. There was one person in chat that suggested to fund to be the publisher for our Linksider game before, but I said no. I don't know. I think for the Linksider, I won't try ourselves. But in the future, we'll see. We'll see. Maybe I will change my mind if we work on the Linksider for one more year and we still did not release it because I keep working on other things. Maybe why did I say no? I don't know. I just want to try it myself. And also, yeah, because like if you, I'm not exactly sure. Like, what are the publishers are supposed to do? They are supposed to just basically they give you funds like money, right? Which is something that I don't really need right now. Right now, I don't really need the money, but they give you money and then you are selling your intellectual property, and then like they are the ones who own the game, right? Take 60% of your income when the game is released, right? So like because I don't need the money like right now, I would rather try it without a publisher. I think if I needed the money right now, I would take a publisher. I think we need a distributor rather than a publisher. Well, but isn't Steam just being the distributor? You just publish your game on Steam, and it's supposed to like advertise it a little bit yourself. Well, I mean, you need to do some work and advertising the game anyway, I guess, right? That's the part that distributors have networks and nice networking. How is it different from publisher? I don't know anything about game development. I never worked in game development. This is basically my hobby. I just want to see if I can release a game at some point. Like I said, hopefully next year we do it. We just need to get back to the Linksider. And the first step to getting back to the Linksider is doing the advent of code. Advertisement is the hardest part. I mean, making a game and coding is also hard. You just need to learn it. And we didn't spend any time learning how to advertise, but we spent a lot of time learning how to code. So yeah, if I didn't want to spend my time learning that, then maybe it would be good to look for someone who does it for us, right? I don't know. Maybe we'll see. We need to like continue working on the game for a little bit first. Also, I'm doing it not solo, but like with other people. If they think that it's worth it to do like publisher, distributor, whatever, sure. We need to agree on something together. We have a team. Yeah, I'm being the coder. We have well, Brainoid there in chat is doing a little bit of music. Do we pay them? Do we think someone pays me? No. We started by doing game for a game jam for free. You can play it, the one game that I'm talking about. But yeah. You're making a game because you're off work for months because of a burnout and white lung disease issues. I have no idea where to go in the end, but I understand what Kubi is saying. I might go the same route and take some time for myself and see how I progress. Yeah. You're 23 years old. I thought I was good programmer. Artina's Titan Advent of Code. Advent of Code is I mean, it's not exactly like competitive programming, but being good at Advent of Code is not the same as being good at like whatever you need to do for your work, actually. You know. But yeah, good luck, Java. Do you have a project in mind that you are going to be working on? Is it one of your gem games? Or no? You already started? Is it one of your game jam games or is it not? It's new? Okay. Like after doing like in the last year we did like 10 15 something game jams, and I think now that I would not start a new game without it being a game jam now, because I want to test if the idea works. And if it's like, yeah, I don't know. I guess you can kind of see it when you start the first prototype just by yourself. But if you see very early that something is really wrong about your game, then I'd rather stop sooner by letting play game people play it on a game jam. Personally, I think you're better in graphics than Pirate Software, so he's better on advertising himself. I'm not watching Pirate Software. I don't know. I don't know. I don't think I'm better than. I don't think being better at graphics makes a difference when you're developing a game anyway. You know, Pirate Software. He's I think he's doing the Godot, right? Yeah. And I don't think that the engine matters. We're doing a custom engine instead. But I don't think it matters when you're selling a game. It literally doesn't matter if you are good at coding, graphics. What matters is the product that you end up with. Game America Studio is what he's saying. All right. Random question: do you use Spotify, Deezer, or Tidal, or another? The Deezer or Tidal, those are also like the music ones. I'm not listening to music a lot. Basically, I'm not doing any music. Kovi's better at graphics than someone. That's interesting. I think he's saying about the graphics programming, not about the paint art that I'm doing. Or are you saying about my paint art? Of the games that we have done? I mean, look at this. I think he's. I think I would say that I'm better than everyone. Yeah, look at this picture. I drew it myself. Yeah, I would say that I'm better for sure. That is pretty good. All right, let me solve Advent of Code here for a little bit, guys. I need to check my theory, right? Check my theory. Let's see. Let's see. So I'm going to do 4. X in 0 to map length. X is X as I32. Let me make this. No, whatever. Whatever. This is X and then Y for Y in 0 to map length, right? So basically, what I'm going to do is I'm going to go over chunks. Here we go. We have a big chunk of a map, right? We have a big chunk of a map, and the area that we can reach in less than a certain number of steps is something like this. So here's what I'm going to do. I'm going to iterate over the chunk position vertically, right? And if the chunk vertically from the beginning is not reachable, then I'm pretty sure that the chunk to the left and chunk to the right are also not reachable. So I'm going to iterate over the vertical chunks from the highest reachable to the lowest reachable, right? And then from here, let's say that we are inside this chunk, I'm going to go left until it is unreachable, and I'm going to go right until it is unreachable, okay? And then every chunk in the middle, basically, so there's going to be one chunk that is partially reachable, one chunk that is partially reachable, or like multiple chunks that are partially reachable, I think. And so like it goes like this. This is completely unreachable, and then this is partially reachable, some chunks, and then there's going to be a big segment of fully reachable. Okay, so for the partially reachable, I will do it by iterating over every single tile in this chunk and seeing what the distance is, right? And for the fully ones, I know just the number of tiles that are reachable there. So I don't need to iterate completely, if that makes sense, right? Does that make sense? So yeah, actually, yeah, let me do this. Let me do this. Reachable. Reachable is chunk X, chunk Y. Chunk X, chunk Y. I iterate over the map, right? The actual X. The actual X is chunk X multiplied by map length plus X, and actual Y is chunk Y multiplied by map 0 length plus Y, right? So if the distance get at the actual X, actual Y is none. No, if it is some, which means that we have calculated the distance to this place. Wait, hold on, this is wrong. No, hold on. Distance at AX, AY. If this is sum, then return true. Otherwise, we return false. But the distance is going to be a function, right? This distance is going to be a function. And before doing that, I need to do what? Yeah, I like skipped a step that I was talking about before. The distance on a chunk is equal to the distance on one of the original 9 chunks, I think, plus the whatever something, right? So first thing that I want to do this will return me the distance, right? This will return me the distance. Let me do the distances to be U64. because I'm going to multiply them. They're just going to be pretty big numbers. So from x and y, I'm going to calculate the chunk, right? Which is going to be x div Euclid by let's do map length be map size, and map 0 length is going to be also map size dot 1 instead. Let me do this. Map size is map 0 length and map 1 length. No, map length and map 0 length. Right? Okay, so I calculate the chunk. And then I calculate the position inside the chunk X. This is the remainder of the division. Right? I'll calculate the chunk and the thing inside the chunk. So I'm going to do this. I'm going to do this. I'm going to do this. If chunk X is not equal to 0, then I'm going to return. I cannot make this a recursive function. Can I just move horizontally and then like I was saying that this is same as that plus a constant, right? Is my theory. But I'm pretty sure this is also the one to the left plus a constant. So in order to calculate the distance to a position inside this chunk, I can go vertically sometimes, and then I go to the right a couple times, basically. Or, I mean, yes, that's what I want. Let's see. This is hard. Basically, I need to go towards 0 until my chunk is either -1, 0, or 1. I'm pretty sure. And that can be done in big steps. That can be done in big steps. So let's see. No. Okay, let's do horizontal chunks first, right? Let me see. Distances at let get distance. I'm going to make another function here, which is getting distance at chunk x, chunk y, and inside chunk x, inside chunk y. This is going to give me also optional distance. This is just a helper. This is going to make the distance hash map that I got from the breadth first search. Right? I'm going to get cx multiplied by map size 0 plus inside x, and cy multiplied by map size 1 plus iy. Yeah, that's it. Copied. All right. Okay. Okay, so here's what we're going to do. I'm going to say that I'm going to get the distance from chunk x clamp from -1 to 1, because that's like the things that I want to guarantee that are calculated. The chunk x is going to be from -1 to 1, and chunk y is going to also be from -1 to 1, and then inside x, inside y is the same. So this is the distance to one of the like 9 original chunks that we calculate honestly, right? So this should be there, so I can unwrap this, right? And then I'm going to add the so we're going to go to the right a couple of times, and then we are going to go to the top a couple of times, right? So I'm going to get the distance on cx clamp from -2 to 2, x, iy, cy clamp from -1 to 1. This is the distance. Hold on, this minus get distance on cx clamp -1 to 1. Okay, does it make sense what I'm writing here? Let me see. So this is the distance to one of the 9 original crates. Then I basically calculate from Nerdzel, thanks for this 11 months, Pog. So basically we go one more chunk to the side from this and calculate the difference between this position and that position, okay? And then I'm going to repeat this difference the remaining number of times, basically, okay? The remaining number of times. So this is the distance, the difference on the x. And I'm going to... This also is going to be unwrapped, because this is still... This is one of the original, like... even more than 9 chunks. And then I multiply this by how many steps I need to go in the horizontal direction. And we need to do the same for the vertical direction. This is not the easiest advent of code either, it seems. Maybe I can write this somehow easier, I don't know. Let me get it to work first. Get distance. No, so now we don't get the distance. Now the number of steps is going to be clamp -2, no, just cx minus cx clamp -1 and 1. So this is the number of actual steps. absolute value of that is the number of steps that I need to go. All right. Closure may outlive the current block. Move. All right. So this is the horizontal steps. And then I do the same. This is going to be horizontal step. Horizontal step. It's not actually horizontal step on X is this. Step X, multiply the number of steps on the X. And then we do the same for the Y. So for the Y is going to be, instead of X, we just do the Y here. And step Y is very similar, but the difference is that. So the distance to a position is an optional, and the only reason it's optional is because it can be a rock. Right? So over here we just say that it should not be a rock. So this is for X and Y. Returns optional tile for our infinite map. Map size needs to be calculated before that. This does not return an optional tile, just a tile. Okay. Expected option, yeah. So if this is not a rock, then it should always be something. So we just check if get tile for the X and Y is tile rock, then we return none. Otherwise, it should be calculatable. Casting of the result of I632 absolute value to U64. Cast absolute unsigned by default. Replace with unsigned apps. Wait, there is unsigned apps? How is unsigned apps different? Without panicking? Okay, sure. Okay. There you go. Now we can calculate the distance to any single thing, right? Let me also say that this is the result. This is the result that we're going to return. Let me first make sure that if the result is like calculated properly, there's apps diff too. Hello there. 0 i32.apps div. Okay, yeah. Lockware 24 Rus. I'll keep it like that. I just need to make sure that this code over here is correct, and I will do that by seeing if this result, this is the basically the math stuff, right? But if I have also calculated the same tile honestly, so if distance get for the X and Y, if we have calculated some honest result, then I want to assert that they are equal. The honest one is equal to the actual result. right? Can't you move out of distance because it's borrowed? There you go. Now it's fixed. Okay. All right. This is going to assert some stuff. I would like to test it somehow. Average Linux user trying to open browser. Huh? Am I trying to open a browser? I can do that. Look at that. My browser is here. Easy. Little reachable. Okay, here's what I'm going to do to test that I did this correctly. For distance, this is going to be called honest distance, right? Let me see. For x and y in honest distance keys, I calculate the distance for the x and y. Okay, I just do it, and this is going to run the assertions, right? Let me try running this. There you go. We actually did something here, right? Print out. Yo, yo, yo. Let me make sure that I actually got to this line. Yo, 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 yo. Okay, so this means I'm pretty sure that... I mean, maybe I need to increase the max fast distance. I mean, I calculated 5 chunks, basically, so this is more than I need. XDG open. Does my XDG open work? I think it might not, because I have... Everyone getting information for file, numbers, PNG, no subfile, or directory. I think it might be, like, not working over here for me on Nix. I never use XDG open. But yeah. Okay, I'm pretty sure this is correct now. So we can calculate the distance to any point pretty quickly. This is basically O1, right? There's no things here. We can calculate the distance to any point. So now we got to this, get to the second part of solving this. I'm going up as high as I can, right? This is the reachable, if the chunk is reachable or not, is what we're going to see here, right? If the chunk is reachable, this returns a boolean. So let's go up until the chunk is no longer reachable, is my idea. So for let's see, highest, let's see, minimum y, minimum x. Let's go on the x axis, sure. Let's go on the minimum x, sure. So I do from negative infinity until 0. Until 0. I take this iterator, I reverse this. Wait, can I not reverse this one? Range 2 inclusive integer is not an iterator. Wait, really? I think they are lying to me. So I want to find the position of the first chunk x that is not reachable on the chunk x, and the chunk y is going to be 0. Right? Range 2 inclusive is not an iterator. That's a lie, right? That's a lie. Why did they lie to me like this? Oh, range 2 is not an iterator because we cannot start. Wait, really? How do I... So I need to do 0, like, to infinity? and then I map the chunk x to be a negative. Is that okay? Right. I wish I could just make an iterator by reversing the range from the negative infinity to 0. But whatever, this is fine. This is the minimum x. So I'm going to go for chunk x in the minimum x to the infinity, to the positive infinity now. To the positive infinity now. Chunk x plus 1 from minimum x plus 1. Because minimum x is the one that is not reachable, right? So min x plus 1 is going to be reachable. This can be unwrapped because eventually we are not reachable for sure. So there you go. This is the chunk x, and I say that if chunk x it's not like just distance is sum. Hold on. Well, I mean, let's do this. Distance is another thing for x and y. I'm going to say that it will actually be distance on xy map or false. But in case we have a distance, then distance should be less than or equal than the max distance. There you go. That's what I want. So like more than max distance is also going to return none. I'm going to filter that option, yes. Is there not some weird formula where you can calculate spots you can visit in your map and then you do something with that number to calculate the number of steps in every direction? The map is the same in every titled direction? Yes, that's what I'm doing. Chunk is basically the map that is repeated. So I'm doing the formula to calculate the distance to a very long away point. Some of the points on the edges of the reachability are going to be like manually like for every single point, and then I'm going to calculate like the chunks all at once because all of them inside are going to be like reachable, you know. So we go until it is completely unreachable. Then I also say that if we cannot reach the chunk and 0, then we're also going to break. And when we are going to the infinity, it's not the position. It's not the position, it's find. The chunk x, the lowest chunk that is unreachable. The minimal chunk then is unreachable, so then we go until the maximum unreachable chunk. Okay. Now inside here, we are going to go from the same but on the y coordinate. Mean y is going to be 0 to the infinity map cy negative cy find cy not reachable cx cy. So this is the minimum y that is unreachable, so we go for cy in minimum y plus 1 to the infinity again. There's like separate stages to it too. Some of them are going to be partially reachable, some of them are going to be fully reachable. But I guess I can iterate over the big chunks. Okay. So I will also need to do fully reachable. So when I can get every single thing inside the tile, inside the chunk, this means that I need to do this, but I'm going to say that I'm going to return false if distance, if I can not reach it, but the tile X and Y is the garden tile, right? So if the garden tile is not reachable, then the chunk is not fully reachable, basically. Okay. So here's what I'm going to do. Let no, this is still bad. Hold on. By calling the reachable here, I'm iterating over every single thing inside. Although at the same time, for the regular reachables, it's going to find the one quickly. Maybe that's okay. Maybe that's okay. Okay, fine. Let's calculate the minimum y and the maximum y. Minimum x, this plus 1. The unreachable plus 1. Minimum y is the unreachable plus 1. Maximum y is the one that is not, is just going to in the positive direction. I find the one that is not reachable, and then I do minus 1. So this is the maximum y, okay, of the like at maybe partially reachable. And then we go for for cy in minimum y until the infinity. If not, so if fully reachable, cx cy, then I want to like break this and continue doing the full chunks. You know? I think I do until 0 here. Separately from minimum y until 0. So until -1 actually here. If it's fully reachable, then we break and we do the remaining ones like fully. Right? So I'm going to also assert that we are fully reachable on the cx when cy is equal to 0. This is something that we're going to assert. So everything from the cx cy until the cx0 is fully reachable. So I add to the answer the number of tiles, garden tiles multiplied by the number of steps, which is going to be well, so -1, because I do until equal to the -1 here. Garden tile multiplies by -1 minus cy plus 1, right? Because that's the number of things that we are going to do fully, basically. The number of garden tiles is the number of tiles inside one tile, basically. Is in one chunk. So we do over here. If get tile xy is equal to tile garden, like that. This is the garden tiles. And we calculate the answer here. Okay, answer needs to be a U64, I think. Type inference is required. Okay, try into U64 just to make sure, because this is I32. This should be a positive integer. Okay, so we do this, and then similarly to this, I'm going to go for cy from the maximum y, from 0 until the maximum y, but I'm going to do this in reverse. And if we are fully reachable, then we're also fully reachable and 0, right? So everything in between the 0 and the current cy minus 0 plus 1, so just cy plus 1. Wait, hold on. Yes, cy plus 1 is the number of chunks that we're going to do that are fully reachable. Okay. And then also, if the chunk is not fully reachable, then I need to like iterate over all the positions inside the chunk manually. All right. So answer plus equal garden tiles. Wait, hold on. This is not. Wait, hold on. I need to also make sure that the things are even. It's not just the number of garden tiles inside, right? It's number of garden tiles that are even, you know. And distance to the x and y is even, right? This is going to be even garden tiles. So since this is garden, I can unwrap. Okay, so now we have calculated everything, all the chunks that are fully reachable, and now on the edges of the fully reachable chunks, we have like partially reachable chunks, which we need to do answer plus equal partial reachable calculate partial reachable chunk at cxcy. There you go. So calculate partially reachable chunk. It's going to return the number of even garden tiles that are reachable inside this chunk. So for inside the chunk, we iterate over all the things, and if let some distance is distance at chunk x multiplied by tile multiplied by map size 0 plus inside x, chunk y multiplied by map size y plus inside the chunk. This is the distance, and if it is reachable, then also if distance is an even number, then we add to the answer plus equal 1. Right? And this is the thing. So this is basically the same as our original solution for the part 1 of today's, but we are only going to iterate over every single cell for partially reachable chunks. So if we, because there's not that many of partially reachable chunks, but there's a lot of fully reachable chunks, I think. Okay, print out the answer. All right. Do I think that this is going to work? Do I think that this is going to work? Part 2 example. Okay. For the part 2 is not working properly. Hold on. The assertion is failed. Wait, but that's for the example. For the not the example, the assertion does not fail. Interesting. Hold on. What's the wrong about this example then? Hold on. I mean, if I run this not on the example. Unwrap or none. Okay. Okay. Fine. Let's run on the example, see what's wrong here. So first of all, we are panicking here because our honest calculation is not equal to the result. Let's see what's our x and what's our y here. X is negative 35, y is 7. So like very high up. I mean, why would this not work for that example? I think the only reason is because I have a bug. Step X. Okay, well, how do I even debug this shit? And to like actually print out the distances, right? Show me the map of distances. Hmm. Let me just read through this first. I calculate the chunk. I calculate the position inside the chunk. The step on X is this. Maybe the absolute value is the wrong. Wait, hold on. So like, our X here is negative. Maybe like something for the negatives should not be. I mean, the assertion worked for the actual map though. That's the weird part, is that the assertion worked for the actual map. I think I might do like clamp -2 and 2 is going to be changed into -3 and 3, and clamp -1 and 1 is going to be changed into -2 and 2, just to be more safe, I think. And the reason is because like the chunk on the bottom, and the chunk after that might be a little different. I don't know. Let's see if this changes anything. No, it doesn't. No, it doesn't. Now 445 though. Now it's a different one. The maximum BFS distance for me to do in the honest. Let's call this max honest distance. Is the map size multiplied by 5. I don't know, let's do map size multiplied by 10. Okay, I do see that so like over here, I increased the thing. I increased the thing, and it made the wrong calculation in a different position now. Hold on. Multiply by 100. This is now like very far away. Is the wrong thing, but it shouldn't matter, is the thing. So like outside of the honest distance is when it's wrong, but it shouldn't matter. Wait, why does it matter? How much honest calculation am I doing? I think it actually doesn't matter. Maybe it's just like the first one. Maybe it's just the first one that's incorrect, actually. Okay, let me see. Step X is distance from this to that. If we are... So let's say that my chunk X is like 100. So I take 100 minus 2. Minus 2. I don't see the problem, to be honest. So is just my theory incorrect? Maybe my theory is incorrect here. That the distance from one thing to the other thing let's do something like for x in 0 to the infinity, if let some distance be honest distance get for x and 0, then we print out the distance, otherwise I break. Let me see this. So we start with 10, 9, 8, 7. Okay, so this is like the first chunk. Let me do over here also if x divided by map size 0 is equal to 0, print out. This is the new chunk. Okay, so here we go. Here we go. This is the first chunk, which makes sense. It's like it's a little different. And then we go from 11 to 21, and then we go from 22 to 32, and then we go from 33 to 43. So it is the same amount. Like I add 11, I add 11, I add 11, right? I add 11. So that is good. What if I try some different y? So for example, let's try the y of 5. Wait, what? Oh, okay. Okay, let's do for x in 0 to like 100. Sure. So no breaking. No breaking. So we just have rocks sometimes. We have a lot of rocks, it seems. Well, these rocks means that I have not calculated them, but let's see the first couple chunks. So this is the first chunk. This is 0 because this is just literally the start. And then I have 10. Then I have 27. And I have 38. So 27, 38 is plus 11. Once again, and then 49 is plus 11 again. So it should be the same. Maybe it's just the distance. Maybe it's not the current distance that should be more than or equal. I should stop if x absolute value is more than or equal than maximum distance. It's maximum distance in terms of like the one coordinate. If this or y, if either of those is more than maximum distance, then we stop calculating, right? So it should be this is the first chunk, this is the second, third, fourth, fifth. So 5 chunks I have calculated properly, right? And it is always plus 11 distance, it seems. Yeah. No, I think it's okay. All right. So then why my assertion is still not correct. For what? For the position 644. For the position 644. Let me make this a binary tree map so that we don't have the random result. The entry though is different type now. Let me qualify the B-tree map entry. Shouldn't matter for the performance anyway. Okay, so now we should have the same result. Okay, 3 and negative 56. So let's do the same, but for the y. For the y, I need to do that. So I am breaking at 3, -56. So 3 and y is what I want to do here. Instead of that. Okay, let's see. Also, I want to print out the y itself. X, y. X, y. X is 3. Okay. 3 -56. Wait, hold on. It's for the negative one. Okay. Sure. Let's do for -100 to 0. I'm going to go in reverse though. I'm going to go in reverse. -56. I just need to go to -60. Okay, so here we go. Here is the chunk to the left. We have 8. Then over here we have 22, which is how much? This is 14 that I added. Then over here, I added 13. And then over here, I added 11. And over here, I added 11 again. Hold on. And over here, I added 11 again. So it started, hold on. So it started not on the second chunk doing 11s. We started doing 11s not on the second chunk. But the first chunk is actually 14. The next one is 13. And then we have... Then we have 11. Okay, so I think it means that let's change clamp -3 -3 to be clamp cxcy with the extra 1, and then clamp -2 -2 is going to be changed into clamp with 0. So this is here's what we're going to have. Clamp is chunk, and extra is going to do something like this. See, clamp. So the maximum is going to be, it seems, not 1 and 2, maybe 3. So from negative maximum minus extra to positive maximum plus extra is what I want to clamp here. Okay, am I going to... I'm not panicking anymore. I'm not panicking anymore. Hold on. What's the answer? The answer for me is 173. This is for the example, right, that I'm running? Yeah. So the answer is still not correct. We have the wrong amount of the garden plots. Let's do for the example... Wait, it's for the 5,000 that I'm calculating, not even for the 10,000. Oh, wait, no, yeah. Okay, let's start with doing this for 6. Option and wrap on non-value. Amazing. Okay, hold on. There is more. Distance. Okay, this is only for the fully reachable though, so it doesn't work with 4. I need to be more than the chunk size. Okay, let's not do 4. Let's not do 6. I mean, let's do 50. 50 should be good. Okay, so for 50, I calculate 1636, which is wrong. Which is wrong. Okay. What about 10? Can I do 10? No, 10 is too small number for that to work. Okay, I think I know one of the bugs that can happen is not all of the tiles that are fully reachable are going to require even. Some need to be odd, actually. So I think I'm just going to, instead of like doing the math here, I'm just going to iterate over all the chunks anyway. So for chunk y in from the current chunk y to the -1, right? Because those are those that I'm going to be fully reachable. They are fully reachable, but then some of them are even, some of them are odd, I think might be the case. Okay? So garden tiles are going to be is going to be an array of 2 based on the evenness, basically. It's going to be U64 2. So std array from fn for the remainder. For the remainder, I'm going to check that the distance divided by 2, the remainder is equal to this remainder. Okay? Yeah. There you go. So then I want to calculate some tile inside the map that is not a garden, which is probably like 0, 0. Okay. Yeah. So I calculate the garden tiles. And over here I do the same. I calculate the chunk from 0 to the CY. Right? Over here. And over here is going to be the same stuff. So it's going to be garden tiles for the remainder, and the remainder that I want is the remainder of the 0, 0. So like the distance chunk x multiplied by map size 0, chunk y multiplied by map size 1. This is fully reachable, so I can unwrap here. This is the distance, and I want this distance to take the I want to get the remainder by 2. So if the distance to like the top left, if it's, hold on, so if it's equal, if it's not equal to the distance to 0 and 0, which is like the original chunk. So for the original chunk, I want to get even, but for the other ones, if the distance is not the same oddness, basically, then I want to convert that into an index. Okay, that's right. Expected nothing, found U64. This is answer SQL. Okay, is this going to work? 1594. 1594. Look at this. Hold on. I think I am onto something here. I think I'm almost done. Let's remove the debug stuff. Let's check the example for 1000. For 1000, the answer is 668, 697. Nice. And for 5000, 167333044. Okay. Let's see how long it works. Let's run it in release mode. Let's run it in release mode, and it's immediate. Okay, so we just run it on the actual input now, and we are panicking. Amazing. So on the actual input, I'm panicking because step X. Okay, so I need, because I'm making 3 chunks in every direction, I need the distance to be a little bigger than that, it seems. Let's multiply this by 10. Clap. It's not clap yet. I'm still panicking. Hold on. What's the problem here? I'm getting the distance to the chunk. It's not a rock. Wait, hold on. Some of the wait, I think I have not seen the input actually, but can it be that some tiles are not rocks but unreachable still? It may be the case. Maybe some tile is just like surrounded by the rocks. Well, let's see this then. Okay, let's see this. It's not get tile, but let me see the reachable ones on the original tile. Let reachable on the origin. Reachable on the origin is going to be distance is filter X and Y, where X is between 0 and map size 0, and Y is between 0 and the map size. So it's the original size basically. This is a hash set of positions in the origin. You have your own advent of code problem, literally trying to divide a map into different regions using Delaunay triangulation. Yeah, that's interesting. Why do you need to do that? For the Kettenberg? I thought it's a card game. Why would you need to do any geometry there? Just for the graphics or for the logic? Okay, so over here, instead of like making sure that the rocks, I'm going to make sure that they are, if it is unreachable in the origin, if not reachable origin contains the ix, iy, then none. In the overworld map, we move between nodes, and I want to generate the map using different environments. Yeah, so over here it is the same. Okay, it is the same. It is the same. Let me make sure that the reachable origin is honest distance keys like this. I need my reachable origin over here. So instead of get tile is garden, I do reachable origin contains X and Y. Is a moved value, reachable origin. Reachable origin the reference to the reachable origin so they don't move it inside this closure here. It's running. It's not panicking. How many tiles are reachable in one step? Probably 2. And now we can see in the input. I mean 4. If you're asking honestly, this is the start. 4 directions is where we can go: left, right, up, and down. This is still running really slowly here. Hold on. Let me make sure that I am doing some printing here. Print out. I mean, let's just do this. Debug CX. I want to see what is the X chunk that I'm currently calculating. Cargo run. Let's also run. Wait, I am running in release. Okay. Oh wait, hold on. These many chunks are reachable? Hold on. The amount of chunks that are reachable is very big. I mean, yeah. I'll calculate one horizontal line, not very quickly, it seems. I mean, hold on. I know why. It's because this is wrong. I'm finding the minimum x and minimum y very wrongly. And the reason is because I basically calculate, iterate over every single tile still. So this needs to be found. I think using binary search is a good idea here for every line. I think minimum x and maximum y should be done using a binary search. Let's do binary search. So binary search is going to be like, so we have the 2 boundaries. One of them is when we are like reachable, right? And then we know for a fact that something is unreachable, right? And I find the biggest reachable thing basically, right? Using a binary search. So I do while reachable absolute diff with the unreachable is more than 1. The middle is reachable plus unreachable divided by 2. And if reachable, the CX at the middle, then we say that, I mean, hold on, the reachable, I have a reachable function that I want to call, and reachable this CY reachable. Let's call this CY reachable. This is going to be CY unreachable. CY reachable, CY reachable is equal to mid if it's reachable, basically. Otherwise, yo, Justin6, hello there, thank you for the raid. CY unreachable is equal to the mid instead. And we basically return the reachable, like in the edge of the reachable and unreachable chunks. I want to find the reachable one. So the minimum y is the binary search, where the reachable one is 0 and unreachable is like negative billion or something. A negative billion. Negative max distance. Can I do this? And then maximum y this binary search to the positive max distance. Okay, let's see if this is going to run better. This needs to be mutable. It should run over the chunks much faster now, but it's not. It's actually slower. Wait, what? Why is it slower now? I'm doing the binary search. Should be better. No, this binary search is slow. Hold on. Did I write my binary search wrong? Jesus. Hello, hello. If I comment this out, welcome Raiders, by the way, I am solving day 21 part 2 currently. Yeah, see, this is wrong. My binary search is running very slowly for some reason. How many do I have? What's my map size? Hold on, what's my map size even? What is my map size? Memory issue? My map size is 131 by 131. It's not that big. I mean, is it? Fully reachable. What if I do max distance divided by map size y? This is going to at least do a little better. But hold on. Memory issue. I think so. Like I changed from my hash map to be a binary tree map, which is like slower. Maybe we use the hash map after all again here. I use the binary tree so that I have consistent ordering when debugging. You haven't even tried Event of Code? Okay, see, like every single loop iteration here takes like pretty long time, even although all I'm doing inside here is a 2 binary search to find the left and right reachable tiles. because my binary search calls reachable, and reachable is too slow, I guess. Reachable, I iterate over all the tiles inside the chunk, which is 100 by 100, so like 10,000 actually. Then inside there, I calculate the distance, which is not a very easy function. Bad memory management is often the issue. Do you know the algorithm? Maybe OBS is it in my CPU? No, it's not. There's some problem here. Maybe. So this should be O1 operation to get the distance. It's a complex function, but it should be still O1, get distance. Yeah. There's just some math happening here. Rust is not usually a good language for that. For what? It's a good language. It's not a good language for what? For me, and just trying to like understand how to solve a problem. Language has literally nothing to do with it. Language has to do with implementing the idea that you have. But maybe my idea, like, I thought it should be running quickly, but it's not. Solving problems? No, I think Rust is very good for solving problems. I can use any language for anything, yes, but Rust is like holding my hand, and like some of the bugs, like I got some of the unwraps here. If I was to write this in C++, for example, instead of unwrap, I would probably just like write it like, I don't know, some implicit conversions between the integers would be there, some like undefined behavior would be here. It would be so much harder to debug if I have written it in C++. If I would have written it in Python, I would also have some other I don't know. No, Rust is actually much better than other languages than to write these problems. The issue here is just that the specific problem that I'm trying to solve is hard. Cargo flame graph can be yeah, we can try cargo flame graph, but I mean, look, I do a binary search, which will require like 30 operations, for example, if we use the i32, right? Like probably less than that, and 30 operations inside there. I'm iterating over the entire map to call this my reachable function, actually, right? Which is also 10,000, which makes it 300,000 operations to do the binary search. So maybe that's why. I think I just need to improve my algorithm itself. It's not the issue with the thing. In other languages it would like run even slower. So the problem is definitely like not the memory or something like that. It's just the complexity needs to be lowered even further. Rust is making you lose some time by writing a fast hash map. No, it doesn't. I was not writing a fast hash map. Huh? Why would I write a fast hash map? It is already written for me. Why would I write it? I'm not losing any time on my hash map. There's a hash map in the standard library. That's what I'm using, yes. Why would I write it? Why would I spend time writing my own one? Mapping. What does mapping mean? What are you trying to say? The problem here is that my solution, independently of the language, is too slow. Okay? I want to calculate the partially readable chunks a little further faster. No, not calculate partially reachable. Hold on. Yeah, I'm just trying to see what. So like my solution right now is we have our map infinitely repeated in every direction, right? So and this is our cloud of richness. For every chunk horizontally, moving left and right again. Like right now I'm doing the binary search to find this edge, right? But what instead if I, while moving from the top to the bottom, right? My edge, I just going to move my edge a little further if I can, or a little back if I need to, basically, right? So that's going to run faster. I don't need to do the binary search. I think that's a little better. Which is going to save me like improve the time by 30 times because the binary search needs to do like 30 operations, right? So let me do mute minimum y is 0 and maximum y is 0. So here's what I'm going to do instead of the binary search. I'm going to do while not reachable cx minimum y while not reachable cx minimum y minimum y plus equal 1 while not reachable cx maximum y minus equal 1. And then before that I do similar stuff but in the other direction. So while we are reachable, we are going in the opposite direction, you know? And that will go like a couple moves to the right and then a couple moves to the left, but not a lot of times, right? Right? This will still require me waiting a lot, it seems. Still feels very slow for a release mode. Hold on. What if I do nothing here? What if I do nothing here? Inside this loop. Then we are going this fast, right? This is how fast I want to go. This is how fast I want to go. All right? Because the number of operations that I'm supposed to do here should be very low. But for some reason it's not. You know what I'm? It's like drawing the circle using pixels. You know, I iterate over the y coordinate and then I find the minimum x and minimum. That's what I'm doing, and for some reason this is slow. So I'm calling reachable, but now I'm calling like I'm supposed like this compared to that should be just 5 times slower because I'm calling reachable not 1 time but like 5 times now. Because even although I have a while here, it's supposed to do not a lot of looping here. You know? and then we can get to the further. What's the problem here? How many of you have solved the day 21 of the advent of code? The day 20 was also pretty hard. Days... You have? Okay. You solved it, took me 10 hours. I mean, if I run this for 10 hours, maybe I will have my answer. I can just wait. I can just leave the program running. How long did it take your program to run? I'm doing this for just 1 hour so far, I think, right? I don't know how much time I spent on the previous one. Run time down to 300 milliseconds. Okay. Yeah, I'm not understanding why is it slow right now. Why is it slow right now? Let me see. Ops plus equal 1. Let mute ops 0. Let me figure out how many operations do I do here. CX ops is what I want. How many operations of like finding the edge am I doing? 6 operations, right? So why is it slow then? Hold on, this does not make sense. It is like, you see, like if I'm doing 6 times calling the reachable function, right? Okay, well, reachable is like, we have the early return here. So if it is unreachable, then it's running a lot slower. Okay, maybe that's why. Maybe that's why. Let's do this. I think reachable needs to be improved. I should not be iterating over the entire map, right? Let's do this. If we are calculating if this chunk is reachable, I need to find the one of the 4 corners that is closest to the origin, and if the corner is reachable, then it is reachable. There you go. This will require 4 operations instead of me doing 10,000 operations here. Because that's like that is enough, right? Okay. There you go. So I do x in not 0 and map size 1. I do x in 0 and map size 0 minus 1. There you go. And then I do for y in 0 and map size 1 minus 1. So the 4 corners is all I really need to check for seeing if the chunk is reachable, right? This is fast now. Okay. This is fast now. Okay. What about the fully reachables? Well, let's see if the remaining part is going to also be running pretty quickly here. Okay, so over here, what is wrong? Over here, we're doing the fully reachable. This is another thing, which is also doing the same shit, right? So what are we doing for the fully reachable? We also just say all the 4 corners are enough. The only reason if all the 4 corners are reachable and we are not fully reachable, I think maybe for the top one, because on the like if we go straight up from the origin, then maybe and like in the bottom and in the left and right, our reachable things can be like this, right? Which in which case not all the 4 corners are reachable, but some of them are reachable, so it's okay. Hold on. No. If all the 4 corners are reachable, then we're fully reachable. I think that's okay. I think we just do the same stuff here. Let's run. Still slow. Still slow. Let's see. Now I'm iterating over all the chunks. Let's not iterate over all the chunks then, right? Maybe I was trying to do the math here before. What's my map size? My map size is odd. For that reason, sometimes we need to find even, and sometimes we need to find odd things. You know what? In order to fix that, let's make... So, like, remember my first thing was me just calculating the even ones, and the reason I changed it is because sometimes I need to calculate the tiles inside a chunk that are reachable with odd distance. So for that, I'm just going to make sure that my map size is even by duplicating it, okay? By duplicating it, make sure map size is even. Map is map into map iterate. Hello, Twitch recommended me this channel. Nice. So every row is going to be converting to double row. So I'm doing row clone, and then I'm doing double row extended. I mean, let me just do this. I'm just going to chain the row 2 times, right? And then collect that, right? I mean, or repeat the row 2 times, flatten, copied, collect, right? That's another thing that I can do, because I want to do it the same over here. I'm going to do iterate, repeat. I'm going to repeat the map. Twice on the rows. Like that. Row iterate. Repeat my iter. Take to flatten. And repeat the row here. Repeat the map. There you go, map. This is going to be the same, back tiles, right? And then this is just going to make sure that my map is twice as big, right? So it's so nice to have a coding buddy. This means that I probably can make this go back to 5. So like the pre-calculation of the honest distances is going to be faster. Okay, so map size is 262 by 262, so it's even. And now, since it is even, I can do without a loop here. I can do a formula, right? So I'm going to do, so since I'm doing cy until -1, right? It's going to be basically -1 minus cy plus 1. This is the length of this, right? I'm going to multiply this by the garden tiles that are even. So the remainder by 2 is going to be 0. And we add this to the answer. So this is going to be a formula. Right? Just like this. And over here, it's going to be a different formula. We are going from 0 to cy, like this. So minus 0 does not need to be here. Okay. Let's make sure that I did not break anything. So run on the example. 167333044. The answer is still correct, right? So my formula is still right. Let's run it on the actual input again. And let's see. This should run fast now, right? Right? No, it doesn't. Okay. What else? So like, what are the other loops that are slow? This is the only loop that I have, the fully reachable loop. From -1 to this. If fully reachable, then we break. Fully reachable. So there is a lot of partially reachable things then on the edges. So like, hold on. So since this is, I mean, it's not even a circle, right? The actual cloud of the reachability, since we're using Manhattan distance, is more like a diamond shape. So let me see how many iterations am I doing here? How many iterations am I doing here? What if every map has the same reachable locations? Minus the steps it took to reach the map from the start? It is exactly the case, yes. But, I mean, something like this. So this is just 6 operations. Hold on, what is running slow here then? Calculate partial reachability then. This thing is slow, okay. Calculate partially reachable. This is only for the edges that are partially reachable, which is supposed to be not a lot of them. Which is supposed to be not a lot of them. Let's make sure that this is the last thing that I need to optimize. This is the last thing that I need to optimize. So the calculate partially reachable is the thing that's running for the edges of the reachability cloud. So here's a big chunk, right, which is partially reachable, which is partially inside, right? So what I'm doing is, for this one, I'm actually iterating over every single cell in these ones. So I'm doing this only for those chunks that are like actually partially reachable, okay? And everything in between, I'm doing fast now, right? So does this mean that there is, like, what do I need to do here? What do I need to do here? Do I just need to optimize this now? No, hold on. How many of these am I supposed to do here? So it seems like operations is 6. 6 times. 6 times on every single one. I'm doing it. I can make sure that my distance function is running faster, but I don't know. This is still... I mean, just optimize that, but I don't know. Am I running in release mode? I am. Let me go take a bathroom break, then I think about it a little more. Okay, I have an idea. It's I never actually checked the things that I'm calculating here. So my current theory is that the number that I need to add for this chunk is going to be equal to the number that I need to add to for this chunk, actually, because this is just like one diagonally, right? Because like I said, it's Manhattan distance. It's not actually a circle, right? So it's we're going on a diagonal line like this. The number of operations is always the same, as you can see, right? So I think the number of things that I'm adding is actually going to be the same. It's only the number of chunks in between that is different, right? So let me just make sure that the stuff that I'm adding here of the partial, right? Okay. Partial plus equal. Partial plus equal. Partial is 0. Operation partial. There you go. Let's see. If it is the same number, it is the same number. Look at this. It is the same number. So why am I calculating this, right? But the reason it is the same number, is it not? I guess, wait, I mean, yeah, it's just like because the edge of our map is just like all empty, so for that reason it is the same. It makes sense. It makes sense why. Okay. So I'm going to do something like let mute partial is none. So I'm going to say, I'm going to basically only if let's see, previous partial is none. Okay, let me do this. Calculate partial is equal to previous partial is none, or CX absolute value is less than like 3. So like the ones that are the ones that are like over here, I'm going to do that like honestly, you know. So something like this. I'm going to do this only if calculate partial. Right? And then if I was calculating partial, then previous partial is equal to some partial. Right? Well, I mean, if we were not calculating it, then partial is equal to previous partial unwrap, right? And then previous partial is equal to some partial, always. So I am debugging this, and then I need to also add to the answer the partial stuff.
Okay, it's running. It's running, guys. It's not 300 milliseconds like someone else did. But it should stop over here. What if this is the correct answer? What do you guys think? Is this the correct answer? Let's see. It's not. It is too low. All right. Maybe I broke something again. Let's run this on the example. Did I actually break it? 167. Yeah, I did break it. I did break it. Hold on. I did break it. Let me do this to be true. If I make this to be true, then okay, yeah, okay. This actually is a bug. Hold on. So the partials are wrong. I see. Over here, it's also like in the very beginning. For the top chunk, when I go to the next one, I also need to do like a couple manual ones. Okay. So let's do this. For CX absolute difference to the minimum Y by absolute value, so like both the top and the bottom, is this, if this is less than like something, then I also calculate them properly. Let's see. This is still wrong. Puzzle ask about odd number of steps. Yeah, I know. My answer is correct if I don't have this optimization, the last one that I did. See? This is the correct answer for the example. And then this optimization breaks some things that I like assume should be the same. So it's either if I have not calculated it before, or oh wait, it's not min y, it's min x that I want to do here, obviously. Okay. Cx, absolute difference to the minimum x. This is for the first one. Hold on. I'm starting with the minimum x. Cx, difference to the minimum x. Isn't this true because I start with the minimum x? Oh, the absolute value of the Cx, difference with the... yeah, there you go. Okay, now the answer is correct, and let's run it on the actual stuff. So yeah, see, the first couple are slow, and then we start going fast. Near the 0, it's going to also be like a couple slow ones. There you go. And then we go fast, and then near the end is also going to start doing a couple slow ones. And then this is our answer. Okay. I think this one must be correct. Shit. Oh no. Hold on. But it's the correct for the example. It is correct for the example. You had like 14 wrong answers for this one. It was not fun. Okay. I mean, sure, let's do this more. Let's do 10. Let's do 10 just to make sure. Because I remember that I had to increase like the chunks like for calculating the actual distance a little differently. Let's make this to be 10 and let's see if the answer is going to be different. It's the near 0. The answer that I got is still the same. This answer is too low. One of the things that can happen, hold on, what is my answer? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Like, can it be that I'm actually like overflowing somewhere? It can be. I'm running in release mode and I'm not checking it. How long will it actually run in the debug mode when I have a little more checks? Really slow. Is Bashcop streaming? Bashcop is streaming. What is this day? 24, okay. Oh, look at this. Hold on. I actually am going to wait for it. But it looks like... Looks like I'm not overflowing or anything. So something is wrong here. Still the same answer that I'm getting, right? Yeah. If I try running the example on... It just looks like you only considered even steps with %2 equals 0. Oh, wait, hold on. Are you saying that I'm calculating the... Yes, calculate partial reachable. Yeah, why am I doing this? This should be equal to 1, right? Why is the answer... So like the answer for odd and even for the example is the same? Is that why? I had this bug all the time. So the remainder here also needs to be 1. Let me see the example. No, the example is now different. All samples ask about even... Oh, wait, hold on. Hold on. Really? Samples ask about... Hold on. Oh, wait. It's like these... All of these numbers are even. And this one is odd. This is... Okay. So this needs to be basically maximum distance divided by 2. Right? This needs to be maximum distance divided by 2. And this over here... distance divided by 2 must be equal to the maximum distance divided by 2. There you go. So now we just run it. This day, not today, yes. Is this the only bug that is left? Okay, I hope so. Now I have a different answer. Nice! Easy. Easy. Only took me 2 hours, I think. I don't remember when I started doing this. Because I did the part 2 of day 20. Okay, let's see the next one. Let's go straight to the next one. Out of have you guys done the other days? So I am left with 22, 23, 24, and 25. Almost 1.5 hours. Okay. Are these hard? You finished all of them? Yeah, but are these hard? Let me commit this. Day 21. Easy. Push. Sand slabs. Enough sand has fallen. It can finally filter water for Snow Island. Well, almost. The sand has been falling as large compacted bricks of sand piling up to form an impressive stack here near the edge of Island Island. In order to make use of the sand to filter water, some of the bricks will need to be broken apart, nay, disintegrated, back into freely flowing sand. The stack is tall enough that you'll have to be careful about choosing which bricks to disintegrate. If you disintegrate the wrong brick, large portions of the stack could topple, which sounds pretty dangerous. The elves responsible for water filtering operations took a snapshot of the bricks while they were still falling. Your puzzle input, which should let you work out which bricks are safe to disintegrate. For example, each line of text in the snapshot represents the position of a single brick at the time the snapshot was taken. The position is given as 2 XYZ coordinates, one for each end of the brick, separated by a tilde. Okay, so we have 3D segments. Each brick is made of a single straight line of cubes. And the elves were even carefully to choose the time for the snapshot that all of the free-falling bricks at integer positions above the ground, so the whole snapshot is aligned into a three-dimensional that all of the free-falling bricks at integer positions. So wait, hold on. Does it mean that only one of the things? So it's either a horizontal, vertical, or like it's along one of the axes here, right? Every single brick. Yeah, it seems like it. 3D Tetris. Both ends of the brick are at the same coordinates. The brick is a single cube. Okay. Because the snapshot was taken while the bricks were still falling, some of the bricks will still be in the air. You will need to start by figuring out where they will end up. Bricks are magically stabilized, so never rotate, even in weird situations like where a long horizontal brick is only supported on one end. 2 bricks cannot occupy the same position. Okay, so just the 3D Tetris. And what we need to do, once all the bricks fall down as far as they can go, the stacks look like this, where question mark means bricks are hidden behind other bricks at that location. Note that all the bricks have settled. It becomes easier to tell which bricks are supporting which other bricks. This is the only brick supporting bricks B and C. Okay. Your first task is to figure out which bricks are safe to disintegrate. A brick can be safely disintegrated if after removing it, no other bricks would fall directly downward. Just determine what would happen if for each brick only that brick was disintegrated. Okay. Bricks can be disintegrated even if they're completely surrounded by other bricks. You can squeeze between bricks if you need to. Okay, so it makes sense. I just need to calculate the number of bricks that that are holding other bricks, which are supported by something else, basically, other than us ourselves. Okay. Let's copy paste this to day 22. The example is this. The only question is I have, what is the vertical coordinate? Y, Z, or X? For any reason, is it X? What is the fall down? Y-axis now go left to right. This thank you brick, which is oriented vertically. So the Z coordinate is the vertical coordinate. Okay, nice. I like the Z coordinate being vertical. Let's take the actual input. Day 22. Okay. Remove that code. Okay, let's parse the input, right? So we have a brick. We have a brick which has 2 ends, right? Which has 2 ends. Ends. 2 ends of 3-dimensional vectors. 2 ends. Okay. I'm going to have the vec3, which is going to have x, y, and z, right? Okay. I'm going to implement the ref for vec3 into 3 integers. 3D image of the example. Did you make a visualizer? We can make a visualizer if we want, but I don't know. I can use something to draw, but I don't want to. Vec3 without capital V is triggering me. What if I allow non-camel case types? Is this not triggering you anymore? Well, I mean, hold on. Here's the reason. This is what I do for my game. Here's my vex. So the reason for this is basically because I can do something like let vector is vec2 xy, right? Or I can do it with the other way in Rust using pattern matching. I can do let vec2 xy to be equal to v, and then this also implements the ref into the struct. So this is a tuple struct actually that I usually use, and then this implements the ref into the struct that's called xy, so that I can do vec.x, and vec.y also works. And then this also implements the further deref into a slice, which like I did here, so that I can also do vec0 and vec1. I don't know. And also, like, this is one of the like if the vec3 without the capital V is triggering you, does it not trigger you that the integer type is also starting with a lowercase I? Is this triggering? Is this triggering? Yeah. Yeah, should char start with a capital C? So for that reason, because this, the only naming like that I'm using is for my vectors, which are basically like the the primitives for me when doing the game development, right? The vectors and the matrices. So for the matrices, I have the matrix, mat3, mat4, for example, just like you do in GLSL, for example. So yeah, for that reason, primitive type, I'm basically treating this as a primitive type for myself and making it lowercase too. And over here, in order to make this the ref, I'm going to do an unsafe transmutation, okay? For that to work safely, I need a RepRC though. Okay. So I'm not going to do the tuple struct into a named struct into this. I think that's fine for me for this problem. We'll see if I need to change it. So here's my brick. It's two ends, two vectors, right? So bricks is a list of bricks. This is the input. We do input lines. We map every line into two ends, which is a line. I'm going to split it once using the tilde, right? And then so ends is A and B. I'm going to map that into end parts is and split using the comma. So I do x, y, and z to be equal to let's do this. Chords is a vec of ints. There's going to be parts. Let's just do this directly here. We split it by the comma and then we map into parsing the coordinate, right? Select that into a vec, and then we convert the vec into an array of size 3. So here's where we change, where we check that we have 3 coordinates. Try into unwrap, right? So these are the ends, and we do brick with the ends, right? And then these are the coordinates. So let x, y, and z to be equal to that, and then I return back 3 x, y, z, like this. Okay. So I need to collect this now into list. Type annotations needed. Okay, sure. This is I32.3. Okay. This is how we read the input. Day 22, part 1 example. Okay. The input was red. So now we just see. Do we just do the straightforward solution for this one, right? So bricks, iterate, filter, can disintegrate. We just count those, and this is our answer, right? So can disintegrate is brick returns a boolean. This needs to be a double reference because of the etcher filter. Or I can, yeah. Sure, because I need to reference the other bricks here. Okay, so what we do is we find let's do for the bricks the equality, right? Sure. So I need to find all the other bricks. How many bricks do we have? Debug bricks length. How many bricks do we have in the... I mean, I can just see the number of lines here. We have 1500. Okay. So we can do a square complexity. The cubic complexity will be too long though. Right? Right. Oh wait, we need to also figure out after they all fall down what is going to be there, right? Oh yeah. Hold on. I think we need to first simulate the falling down before we do the disintegration, right? Yeah. Okay. Sure. 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 Let's do this. Bricks is... Let's do this. Let's do this. Function make fall bricks. This returns the new set of bricks, basically. I don't know if we will need this as a separate themes. What is that supposed to do? Hello there, Molly Ape. You're asking about the VS Code theme, then I'm using the OneDark. OneDark Pro theme for my VS Code. Make fall the bricks. So here's what I'm going to do. I'm going to my bricks. They are going to be sorted by key, which is their bottom part, basically, right? Let me also make sure that I normalize the ends. Hold on. So this is that. Let me make sure that the first end is smaller than the second end, because it doesn't really matter. And I want to normalize my input, because we sometimes go in negative direction, I'm assuming. Do we? Maybe we don't. Maybe we don't. Hold on. Let me assert. Maybe. Let me assert maybe. For coordinate in 0 to 3, assert that ends 0 at the coordinate is less than or equal than ends 1 coordinate, right? Can I do that? For the example, it works. For the actual, it also works. Okay, so they actually do it. I don't need to make this myself. That's good. I like that. So we can basically have the brick in like a form of a bounding box almost. We have the minimum coordinates and the maximum coordinates. All right. Now we make the bricks fall. So I'm going to, once again, over here, result is this. I'm going to sort my bricks by brick and the first and z coordinate, because this is the minimum z, so like the lowest part, right? So I'm going to process the lowest bricks first, so they are going to land, and then after them, the bricks that are higher than them are going to land, basically. Right? So for brick and bricks, I need to figure out where it lands, right? So in order to figure out where it lands, I want for every single tile. How long are my bricks, by the way? How long are my bricks? Let me do this. I want to debug to show the bricks, iterate maximum by key, brick, and 1 minus brick and 0. Let me do brick length, like size. Okay, let me do it as a method. Sure. This can be unwrapped because I have at least one brick. So for the brick, size is self and self ends 0. Array zip is not there. Okay, so we do 0 to 3. We map for that, and 0. This is the coordinate, and the coordinate minus self and 0 coordinate plus 1. Max unwrap. Okay. So this is the maximum size of a brick. I just want to see it. Let me do not the max by key. Let me just do the map brick size max. Right? I want to find the maximum brick size, which is 5. Okay. 5 is the maximum brick size, which is great. This is great. Okay. So here's what I'm going to do for brick and bricks. I want to know what is the highest place for every single coordinate on the XY coordinate, right? So highest is going to be a hash map from the X and Y. From the X and Y. Okay, I want a vec2 then too. Whatever. Let's just for the vec2 use the array of this. So for every XY coordinate, I want to know the highest Z coordinate, and probably the brick that is going to be supporting this thing. So yeah, actually just the brick is what I want to know. Right? The brick in a form of an index is okay, I think. The index in the result. I mean, technically, we can just make them full here. So we like mutate in place instead. Immutable bricks then. Okay, so I make this brick fall down basically. When we make them fall down based on the lowest Z coordinate. First. Okay, so over here I need to figure out where it's going to fall, right? So the Z that is going to be there is so I want to find like the area for the brick area, brick XY area. XY. I just want to have this method here for as a helper. XY. This is going to return me the iterator over all the X and Y coordinates that I have, right? Yeah. So it's going to be self and 0, 0 until self and so like to the second and 0 coordinate, which is X. So yeah, the lowest end to the highest X, and then I map those into self. This is the X. I do flat map actually. From X into self and can I copy the ranges? Let me do this. X range is this, and Y range is the same, but we do dot Y, right? So X range, we flat map this X into Y range, map, move, Y, X and Y. Okay, so this is all the X and Ys that our brick is covering. Cannot move out of Y range captured available because the range inclusive does not implement the copy trait. Why does it not implement the copy trait? This is the inclusive range. Clone. Yeah, the inclusive ranges. Can we fix them? Can they fix them in Rust 2024? Range has a built-in. Yeah, I remember. For the range inclusive, there is an exhausted boolean because this is the iterator. Yeah, I know, but it's annoying. I would rather have to convert this into iterator manually, you know, than it be in the iterator immediately. It needs to implement into iterator, but and not implement the iterator directly. Okay, so here we go. Bricks XY. I have all of those, and I find for the XY, I map the for the XY, right? I want to find the highest get for the XY. So if there is something underneath this XY position, right? Then I'm going to fall on top of it. Otherwise, if it's not there, then I'm falling onto the Z equals 0, right? But if it is there, index, then I get... Oh, but then I need to have the brick in the previous one. Okay. This is a little harder if I store the index here, because I am not allowed to do that. Okay, let's do this. Current index in 0 to bricks length. I'm doing it this then. So brick. Or I can go back with the result, you know. Let's go back with the result with capacity bricks length, even though it doesn't really matter. I'm going to return the result instead, and I'm going to do for brick and bricks after I have sorted them. So I get from the result the the brick, and I want to find the maximum and a z coordinate, right? So this is the maximum z plus 1, and this is where we are actually going to fall. Okay, so this is also a vector of bricks. Okay, so this is the z where we have fallen. Into the result, I'm going to push the brick. Although the brick, I'm going to mutate it, right? So only the z coordinate is going to change, right? Yeah. So brick. So fall distance is going to be equal to brick ends 0 z minus z. So I do for and in brick ends, brick z minus equal fall distance, right? Z. So yeah, for every xy, I'm calculating the thing, and I'm going to fall on the highest z coordinate, basically, right? We can unwrap this because we have at least one xy. Not brick, but and z minus equal fall distance. Okay, so here we go. This is how we have fallen down. And then after putting this brick into the result, and to make sure that we update the height map, basically. This is the height map, actually, is what we can call it. So we do basically for xy in brick xy's, we do height map, insert for the xy, brick, the lowest and z, okay? No, not this. Just the index of this brick. This index. This index is result length. There you go. So this should make them all fall down pretty efficiently here, right? And now we want to know if I can disintegrate them after they have all fallen down. In order to do that, I mean, it is actually similar. I want to do it immediately here, I think, without even falling them. This is fallen bricks. In order to figure out if I can disintegrate it, I want to also know which bricks support which bricks, right? Which bricks support which bricks. Let's hold on. Let me call this support z, which is going to be just the maximum z of all the things that we are falling on. And fall 2z is support z plus 1, right? There you go. So now I can figure out what are the bricks that we're actually going to be supported by. I think I do it without a function then, you know? I think I do it without a function. Here's what I'm going to do. Fall distance. I want to know what are we supported by. Supported by is brick xy map y Hold on, let me do this. Bricks below is equal to brick xy flat map xy height map get xy copied, and then I collect those into a hash set of indices of the bricks that were supported by, basically. Okay, so support z is bricks below iterate map the maximum z of the bricks below, basically, right? And then the bricks that were supported by the bricks that were actually supported by is similar. Bricks below iterate filter the index colon index ends 1z is equal to the support z. So all the blocks that are strictly below, are like at the same z below us, are the bricks that are actually supported in us, you know? What do you usually stream? On this channel, game development. I'm making a game. You can check it out over here. Or like game jams, for example, is what we do. Here's my main project that I'm working on. It started from a game jam too, and I can do and all of the other games that I made are over there. I'm using Rust for game development, my own custom engine. We do game jams, and we're trying to make one of those games into a full game. Last game jam that we did was the Bevy jam. So I used Bevy for a little bit too. But usually we use our own custom engine. Supported by is a hash set of indices. Okay, there you go. How long have I been coding with Rust? About 7 years. You have no respect who do game dev. It's hard and thankless. Yeah, I have earned 0 money using doing game dev for so far. Even though what I'm doing to earn money is a little bit related to the game dev, but not exactly. Supported by is a hash sets. So this is like the list of bricks that I am supported by. Okay. 7 years. How did you discover Rust? One of my co-workers, when I was working back in the day, she told me that. Well, I was trying to do a specific thing for work, and I was like this is slow, all right. And I tried like TypeScript and some other languages. I don't remember why exactly, but my co-worker suggested me to look into Rust. He ended up doing Golang instead, which is yeah. But I heard about Rust from my co-worker originally. I recently started to write Rust with 3 years of experience on web dev and love it so far. Nice. Go makes me chuckle too. It's okay. Yeah. Yeah. Go, Python, I don't know. Though you know what? Actually, this makes me think. The languages that I hate the most, which are Go and Python mostly, are the languages that I think are very good for beginner programmers, though. So which one is better, Go or Python for a beginner? I actually, so far, I have been thinking that Python is better because it's dynamic, but maybe Go is still simple enough to recommend for the beginners instead of Python. What do you think? I'm not recommending Rust to someone who is new programming, for sure. But Go should be at least better than Python because it has types, some sort of types in the language. You would prefer Go as a beginner? Yeah, I think like I don't know what I would prefer as a beginner, because some of like Python as a language makes more sense to me than Go, to be honest. It's just Go has the static typing, which prevents a little more mistakes, and the language is still simple to learn. I go against the grain about Python. I think it's very bad for beginner. Why do you think it's bad for the beginner? The reason I think it's good is because you want, like, it allows you to make a lot of mistakes. Dynamic typing allows you making mistakes about types, making mistakes like a lot of other things. So in the beginning, when you're learning, you want to learn by doing mistakes. That's why I think Python is good. The conventions in Python are somewhat too different, like the inverted if and so. What is the inverted if in Python? The if, like A, if condition, else B, the ternary operator, just don't use it. And also it's different from other languages if you know other languages, right? Which is usually like condition, then A, other B. I don't think it matters. I don't think it matters. When you know nothing else, it doesn't matter. Python teaches bad practices because it allows too many mistakes. Okay. Yeah. I guess. I don't know. Do people like? I think also like the beginners like, do they actually start with Python, or like, I know that Scratch exists right now. Scratch is actually more typed than Python, right? So maybe Scratch is the thing. And then from Scratch, you can go into an actual programming language, and it should then be like something like Go instead, then. Maybe. When I was learning programming, there was no Scratch. I don't know. That might be the correct path. The faster path. People are too embarrassed to use Scratch since it's kid themed. I don't know. You need something serious? Okay, start with Rust then. Start with C++. What a good choice of a language to get started with, right? When teaching my daughter, you started with JavaScript. She didn't think about types at all. Yeah, and you don't need to think about types. Like, I remember... And you switched to Rust after a month or so? The fastest path is to learn hardest thing you are capable of learning at the time. Take maximum byte. Yeah, but how do you know what is the hardest thing? She gets Rust just fine, but how long after starting with JavaScript? So how long after being the beginner? So are you saying that teaching Rust as the first language is a good idea? I don't know. There's like just too many things, which like, even for an experienced programmer, I think take a lot of time to like understand the borrow checker and everything. Going from JS to Rust helped me about thinking about errors and a lot, since no proper error handling exists in JavaScript. What do you mean? There's try catch, isn't there? I never used try catch in JavaScript. I'm teaching a teenager Rust and he gets it, he's just lazy. Yeah, so like you want to be lazy. I get it. You want to be lazy. So for that reason, I don't know. Like things that are annoying, like people are saying that Rust is annoying because it like you need to like fight the borrow checker or whatever. You need like actually write out the types, and in the beginning when you're learning programming, you want to get at least some result, even if that result is a mistake, is a runtime error. So you want the like, even although you have an error, you still have like something is working, you know, at least something is working. So for that reason, I don't think Rust is the best. Anyway, let's continue the brick problem here. We are finding the things that were supported by, and if any of those is supported by anything. Well, supported by is going to be saved basically, right? Let's mute. Supported by is going to be a hash map from let's do it back, sure, of a hash maps of indices. So I'm going to do supported by push. So for that brick, we have calculated what are we supported by. And then after that, after we know for every brick what is it supported by, we do something like for this index in 0 to bricks length, right? Let's also do not supported by, but like supports what brick supports what brick, right? So like supports is going to be a vac of this is a vac of hash sets of indices too. Hash set new, and the size is brick colon length. Okay, so I want to see if so can disintegrate means that all of the bricks that are supported by this one if any of those this is the supported brick, if any of those is only supported by this one, so supported by for that brick, if it is only supported by this one, so the length is 1 basically, then we cannot. So not is here, let mute answer is 0. So if can disintegrate answer plus equal 1. Bricks has been moved, so let's do fallen. Supports what? I don't like the for each though. Hold on. What? Replace the for each? Hold on. What are you saying to me here? Clippy is saying that consider using an iterator supports no, I don't know, I don't want that. But this warning is correct. Allow Clippy needless range loop. Okay, so the supports needs to be calculated though. So we do for this index in 0 to colon length. I do for supported for below and supported by, for this index, I say that that the brick below supports this one, right? Need this loop range. Iterate, enumerate. No. I don't like this clippy lint. I don't like this clippy lint. I don't know. I'm not sure. I'm going to allow that. And we have a support Z here. Bricks below, max, unwrap, or 0. There you go. Now when she wants to put a reference to a struct, I'll just gloss over. Skip run lifetimes until it comes up in the wild. Dynamic languages are easiest for people who forgot how to count. Oh, I missed a bunch of stuff in chat. All right. When I want to put a reference, I usually use the arc or RC. I don't do the lifetimes a lot of the time. I think most of the time. Okay. Okay, answer is... Let's do the example. For the example, the answer is 5. 5 bricks can be safely disintegrated. And then we do the actual part 1. The answer is 495. This is the right answer. All right. I didn't even need to debug this at all. Continue to part 2. Disintegrating bricks one at a time isn't going to be fast enough. While it might sound dangerous, what you really need is a chain reaction. You'll need to figure out the best brick to disintegrate. For each brick, determine how many other bricks would fall if that brick was disintegrated. Okay, disintegrating any other brick would cause no other bricks to fall. So in this example, the sum of the number of other bricks that would fall as a result of disintegrating each brick is 7. Disintegrating any other brick which cause no other bricks to fall. So in this example, the sum of the number of other bricks that would fall as a result of integrating each brick is 7. Disintegrating brick A, disintegrating brick F. 6 and 1. What about the other? Oh, any other brick would cause no other bricks to fall. Okay. For each brick, determine how many other bricks would fall if that brick were disintegrated. What is the sum of the number of other bricks that would fall? Okay. All right. So we have basically a graph now. We now have a graph of bricks. This is a brick, and this brick supports that brick and that brick, and then this brick supports like some other brick, right? We have an acyclic graph here because the support means that we're going higher. The graph is acyclic, and for every brick, we want to know how many bricks will fall, which means that how many of those that we can reach, but at the same time, wait, hold on, how many do we have? How many bricks do we have? We only have 1400, so I can do it, I can do the simulation separately for everyone. I was just wondering if we can solve this in linear time instead of quadratic time, but I guess we can just do the quadratic. Doesn't matter. Don't need to be too smart here, I guess. Let's go if part 1, then we do this, and otherwise this is part 2. I want to know how many bricks will fall if I disintegrate a specific one, right? So for index in I mean for this, like this starting brick in 0 to fallen length. Let me allow the needless range here too, just in case. So I'm going to do this in linear time here. I'm going to say that number of supports, right? Number of supports is going to be equal to number of supported by is going to be equal to supported by iterate map the length of the, like the number of bricks that were supported by, and we just collect that into a vec. So this is just a list of numbers of our supports. And then we start actually disintegrating blocks one by one by doing a queue, okay? So queue. It doesn't even have to be a queue. We can do a vec, a stack, it doesn't matter. So what I want to do is to disintegrate the starting brick, right? So while we have still something to disintegrate, disintegrated is any one of those that we still need to disintegrate, right? Basically I go over for above brick in the list of bricks that this brick that was just disintegrated supports, right? I can also do something like this instead of iter copied, I guess. So this is the brick that's directly above us. I'm just going to say that number of the bricks that the brick above is supported by is going to be subtracted by 1. And if this number of became 0, then I say that this one should also, the brick above should also start being disintegrated, basically. Right? So this is a mutable queue. And then I say fallen plus equal 1. So this is how many have fallen down. Right? So fallen. And we need to calculate the sum of that, right? So to the answer we add the fallen -1 because we don't count the original one that we disintegrate, right? And this is our answer. Okay, so for part 2 example, the answer is going to be 7, and for the part 2 actual one, the answer is this. Okay, this day is so much easier. And now we have 3 days left. Let me go get some tea. Mid day 22. Day 23. A long walk. The elves resume water filtering operations. Clean water starts flowing over the edge of this island. They offer to help you go over the edge of island too. Just hold on tight to one end of this impossibly long rope and they will lower you down a safe distance from the massive waterfall you just created. As you finally reach Snow Island, you see that the water isn't really reaching the ground, it's been absorbed by the air itself. Looks like you will finally have a little downtime while the moisture builds up to snow-producing levels. Snow Island is pretty scenic, even without any snow. Why not take a walk? There is a map of nearby hiking trails, your puzzle input, that indicates the path, forest, and steep slopes. You are currently on the single path tile in the top row. And you want to find the single path tile in the bottom row. Now, because all of the mist from the downfall, the slopes are probably quite icy. If you step onto a slope tile, your next step must be downhill. The direction the arrow is pointed to make sure you have the most scenic hike possible. Never step on the same tile twice. What is the longest hike you can take? The longest hike you can take. Wait, what? This one, this was fun. Hold on, how do you find the longest path instead of the shortest path? I am seeing some things in this map, though. I'm seeing some things in this map. It's also like... Is this graph actually like acyclic? Once again. I think this one is. It looks pretty acyclic to me. I can't go the same square twice, right? Yes. Yes. But still, like, how do you find the longest path? In case of an acyclic graph, you can't go to the same square twice. No, you cannot do the same square twice. Not because of that, no cycles. You can, it could have easily been a map. Let me start doing this. Could have easily been a map, for example, where we have a dot here and a dot here, right? So that you can go right and then down and then down and then left and then up, right? And start going in a cycle, right? Even without the no cycle rule in the hike that we want to find. It really depends on the map here. And I need to check if it actually is a cyclic. This example, from what I see so far, is, but the input that we're going to be given, yes, without the same square condition, is it a cyclic? And like, because it is a path, this is what it looks like. So like, we start over here. The only way that we can go here is over here, right? And then we only can go over here. And whenever we have multiple ways to go, like over here, right? It basically, like if we have multiple ways to go, that we cannot go back to this tile, you know? So that's what I want to check. With these paths, it is a cyclic. Okay. Well, I had to check it myself. I'm assuming you're saying this because you already solved it. But it doesn't say that it is a cyclic in the description of the problem here, okay? That's my assumption. Like, for example, they could have made a map so that the slope goes down and we cannot get out of it. That's another thing. But no, if we have a dead end, it doesn't matter. The dead end doesn't matter. Okay, let's construct the acyclic graph. I mean, we're just going to do that, just do the DFS anyway. Right? This looks like it's done similarly. It's basically like a maze that they have generated here, right? But in mazes, you still can have cycles, is what I'm saying. Day 23 input. All intersections are surrounded by this. Oh yeah, there you go. But that's just kind of a spoiler though for myself. Okay, that's a spoiler. That's not really said to us in the problem statement. So you made my my problem solving here a little easier by spoiling it to me. But I had this assumption anyway, so it's alright. I just didn't have the time to check it before being spoiled. Okay. Okay, map. Oh, so we have once again tiles, which is going to be path. Forest and slope. Slope in the direction. Let's say that the vec2. I'm just for this one. I'm going to say that vec2 is equal to int 2 ints, like this. Okay, so we have the tile. Now we need to parse the map. It is dot, then it is the path. If it is this, then it is a forest. If it is this, then it is a slope, which goes. So since I'm doing row column, this is going to be the same row, but the previous column, right? And we have this for the next column. We have V for the next row, and we have for the previous row the caret, right? This is a method. All right. Day 23, part 1 example. The input we have, so now I need to find, let me take a look at my input too. So the entrance is always here, it seems. And the exit is always the right one underneath. Okay. Well, anyway, let's do entrance is 0 to map 0 length. Hold on. Map 0, iterate, position, the tile, where tile is the path, right? So this is the entrance. It's the first row and this column. I convert that into, I will unwrap this because it always exists, and I will use in i32s for my position. And then I will also have this get tile, just like before, right? for the position, which is 2 integers like this. Row and column are 2 integers. This returns the optional file. I mean, we are surrounded, so this is the only exit, right? Think so. So for that reason, let me just do the tile then. It's just going to be map row converted to usize. Just to make sure we do that. Let me do this position. Let row and column be position map x extra into unwrap. So row column is 2 usizes basically. So map row column is what I'm returning here. Entrance. We have found the entrance. This is a vac2, by the way. Okay. So basically, we're going to have a function that's called solve. I will need this function to be recursive, though. Which means that the only thing that I don't like is when I need to do a recursive thing, I cannot do a closure anymore. So I will have to do something like struct struct like solver. Okay, I'm going to have a map. So bad cop with a raid, does that mean that bad cop has solved day 25 and all the days? I'm currently on day 23. But can you solve it in bash? I'm pretty sure I can, but I'm not a masochist, alright? So let's do it in a actually good language like that. You streamed 15 hours. Nice. What was the hardest one? I would assume that it is this one, day 21, I think. Competitive programming won't save me. It's alright. I have other skills than competitive programming. Hold on. It's a math problem. But competitive programming is about math. Mostly. But this is just raw math? Alright. I'll see it. I'll see it. Okay, solver. Let me just solve 223 really quickly here. We just need to write a DFS here. So map. You copy pasted someone else's solution? Wait, what? That's not math. Math is when you like. Oh, but you piped it into the BC. All right, that is proper coding. Sure, I see. Okay, we have the map. I will have the visited, which is going to be hash map from position into the visited, which is going to be either not visited or processing or done. Alright. This one nearly ruined you. It ran so slow. Why would it run slow though? You just need to do a DFS here, no? Bash doesn't like looping. Isn't there a trick that you can use to make it like the things? Is there like, hold on, can you not? Maybe for the here's the thing for you for the next advent of code. So you know how like in JavaScript there is a thing that's called ASM.js, right? Do you know what this is? Subset of JavaScript designed to allow computer software written in languages such as C to be run as web applications. Okay, so can you do a bash asm.sh thing and then write a compiler from Rust into the bash into asm.sh so that you do it this way? Here, is that a good idea for your next advent of code? You can't store binary data in variables, so you have to keep all data in hex. Yes. Wait, hold on. Why can you not store it? Because you cannot expand it then? But you can keep them in temporary files. And the temporary file can be in TMP-FS so that it's quick. No? And then you like pipe things around. TMP-FS is not that quick. We use some for the advent of code, alright. Well, yeah, it still needs to like create the file and everything. It's not as quick as just using the RAM, I guess. Not as fast as I am. Alright, I see. Okay, we need to have the solver and we need to solve the thing here. Impulse solver, function solve for self, and we solve starting with the vertex, with the position, right? And this will give me the answer, which is the longest path, which is going to be usize. Okay. So we solve starting with the entrance. Okay, there you go. So first of all, we are going to end if we are on the last row. So if position x, so like the first, so the row is the last one. So map length -1, then we return 0 because we are already in the end, right? Otherwise, we see if we have visited ourselves already. I think I also will need the previous. Previous is optional so that I don't like go directly back. Previous is none originally. If we have visited match if self visited get, going to do a match here, right? Match self visited get for the position. So if I have been there, I guess not visited is not going to be here. It's either visited because we started processing or because we're done. There you go. So if it is processing, this means that we have found a loop. So this should be unreachable technically. I'm just like, I have already been spoiled, but I I wanted to like try and detect the loops here. If it is visited done, then I have calculated the answer for this one actually. So done result, then I just return the result here. And if it's none, then I actually calculate it, right? So I do self-visited, insert for the position. We are starting the processing of this thing, and then we calculate the answer. So we go for directions in based. Okay, let's do the directions that we can go. Can go is based on. I guess this can be a method then. This over here can be a method. Function get tile self position. Okay, so match self get tile at the position. And if it's a path, if it's a forest, then it should be unreachable for sure. Or actually, you know what? Yeah, let's make it unreachable here. I'll check it in the other place so that I don't go into the forest. If it's a path, then we can go all the 4 directions. So it's going to be negative 1, 0, 1, 0, 0, negative 1, and 0, 1. So this is all the directions. This is part 1. I don't know about the part 2 yet. And if it's the slow direction, then it's just the direction. Okay, I make this a vec so that it's the same type. Or can go is a vec of directions that I can go. So for direction and the directions that I can go, the so x y is the current position, dx dy is the direction, dx dy. So new position is x plus dx and y plus dy. So then I say that if self get tile for the new position is not the forest, then I say that the answer is result, I max it with the solving using the new position, and our previous position is the current position. And also this reminder that I need to check that if new position is equal to the previous position, then I continue and I ignore this so that I don't go directly backwards. Right? So then result is none, and I update it with this. And then I basically insert into the visited for the position. Now we have now we are done processing this one, and the answer is result, which can be unwrapped now, unless we have a dead end in the labyrinth in the labyrinth here, but I don't know if we have it or not. And then we return the result. So yeah, this return is not necessary. All right. Let's try running this. It doesn't compile because the previous is now some position. Yeah, this is optional. Nice. Now the only problem is I am going into negative positions, it seems. Right? Yeah, I'm going into the negative positions. Well, because from the first one. Yeah, okay. New position. I guess we just check it here then. If new position 0 is less than 0, continue. Sure. I don't need to check it for the exit. It's just so that we don't go up from the very beginning. Okay, then we have another panic over here. This means that there is a dead end. Hold on, is there actually a dead end here? Unwrap or else. Panic. Dead end at position. Is it? At 1813. Let me see. 1813 is like over here. This doesn't look like a dead end. This doesn't look like a dead end. Let me say can go. Which ways could I go? Sure, I'll clone it here for now. I can only go down. Okay, so this is actually for this one over here. Because VS Code showing me the lines and columns in 1-based indices, and I was out doing them in 0-base. So for this one, I can go down, and this probably has been calculated already. Right? Result. Oh, wait. Oh, wait. I'm trying to go up. Okay. I see what happens. I went into this thing from below, I'm pretty sure. And then I'm trying to go up, right? I'm trying to go up. So then I cannot go backwards, basically. So I need to make sure that I don't go there. Right? I don't want, if we have previous be equal to, if we came from somewhere, or I guess, hold on, if the tile that we're standing on is a slope with this direction, if it is a slope with this direction, let me just return optional here, you know, so that like dead ends are just going to be considered properly. So over here I will unwrap, and over here it is this. And by the way, I have forgotten that after doing one turn I need to increase my distance of travel by 1, right? So over here I am returning 0 because I'm already in the end. If I'm done, this is going to store an optional usize. Sure. So I'm not going to unwrap basically here. right? But I want to make sure over here, for example, too. I'm just going to delete the incorrect move. So if position 0 less than 0 or position, yeah, if this, then we return none because we cannot go over like up from the beginning. And also if I'm on a slope, then if position plus direction is equal to the previous point where we came from, then I should not have attempted this, basically, right? Okay, sure. Optimizing already? No, I'm not. What do you mean? This is just the regular thing here. Okay, get tile still panics here for when I'm... Okay. Sure, I will do this. I will do this here, fine. If new position 0 is less than 0, continue. It's the same bug. I'm going out of bounds. Alright, answer 94 for the example. Is that right? 94. Okay, it is right. Let me run this now on the actual input. And it is 2050. Submit. This is the right answer. Okay. Part 2. Let's see. Is it actually harder here or not? As you reach the trailhead, you realize that the ground isn't as slippery as you expected. You will have no problem climbing up the steep slopes. Now, treat all slopes as if they were normal paths. You still want to make sure you have the most scenic hike possible, so continue to ensure that you never step on the saddle twice. What is the longest hike you can take? Okay, so now the thing actually has the loops. Okay. Rip you. Now the thing actually has the loops. Okay. I see. Find the longest path.
Find the longest path. Whoa, find the longest if you said P is MP tonight.
Okay, but it is a pretty specific graph here. I'm pretty sure that this graph is specific. This graph is pretty specific. And one of the types of graphs that would still allow me to solve this problem is called a cactus. So I'm wondering if this is a cactus here. Do you know what a cactus is? Let me check this here. A cactus. Yeah. It's basically the loops, but the loops, they never... Like, there is only simple loops. So, like, the loop only... There's... Like, there is no intersecting loops, basically, in a graph. Then it's a cactus. So it's like if you have a loop and then you have another loop and then you have another loop and they are like connected to each other, you know, then this is like a cactus. All right, this might be a cactus. Wait, did you not solve this problem? How did you do it? RNG? So if this is a cactus, then you can treat it as a path. So in order to get from one place to the other place, you calculate the distance on it. So like the nodes that are loops, they are like nodes, and then this is like, you solve it brute force-ish. Okay. So on a cactus, you just, in order to find the thing, you go here, and then in order to get to the next like loop in the cactus, you want, for the shortest path, you take the shortest path on the loop, and for the longest path, you take the longest path on the loop. Because if this is not a cactus, then I don't know. Just brute force, like, I guess you have some. Yeah, I guess just we just make this recursive, right? Properly, and then you have the brute force. Okay. Can I visualize it a little better, though? I don't like how it looks here. You want to see if it's a cactus? Very exciting. All right. Sure. Let's see if it is a cactus. How do I check if the graph is a cactus, though? If I remember it. So like we see over here, we are processing, right? So this means that I have found a loop, basically, right? This means that I have found a loop. And how will I store it also? How will I also store it? I don't think I ever have written any code for the competitive programming where we were solving the cactus problems. I just know that it's a thing that exists. I don't think I ever have written code for that myself. So I think I'm going to store it as a as like the loop, like, right? So loops is going to be like, I think basically the every single vertex in a graph, every single vertex in a graph will, so this is like the vertex, which is the position for me, right? This is going to store all the vertices in that loop in a list, you know. So it's going to be a vec of the, like that. I think this is the loops that I'm going to have. Right? I'm going to have it here, loops, hash map from a vec 2 into a list of other positions. So whenever I'm doing my DFS into a vertex that was processing, it means that it's no longer unreachable, right? So yeah, over here I disallow going. So like slopes, yeah, slopes. This is all directions, right? And we can go, if we are doing part 1, then we're doing this. Otherwise, we just go all directions, right? Part 1 is just a Boolean. If we are solving the part 1 or part 2 of this advent of code, part 1. Loops. We initialize it to no loops. Let me just make sure that part 1 still runs, but then we have the switch for part 2. If slope direction is this. So we only run this basically if if we are on part 2, then we allow going slopes. We just ignore all the slopes here, right? So for the part 1, wait, the answer is different though. What did I do? What did I do? Why is the answer different? $74, no, 94 is the answer, for example. Wait, what did I just write? I didn't do anything yet, right? We can go in all directions if we're part 2, only when we are on a path. If we are on the slope, then we go into this direction. Otherwise, we go... and check all the things. Wait. Control Z. What did I do? Let me undo the changes, because I'm pretty sure that I should not have broken anything. $94. Okay. Hold on. Part 1. If part 1, then we do this slope if, otherwise we don't. Over here, if part 1, then we do this. Otherwise we can go in all directions. I'm just writing the same thing. Still 94, okay. What was different? I didn't see anything that I did differently. Okay, and then we have the loops that we're going to be detecting. Like that. Let me make this a separate struct so it's even like fast. It's super fast. So here's what we're going to do for a loop. It's actually going to be the positions, which is a list of positions, and for the position index into the loop. Index is a hash map from a position into the index in the loop, right? Okay. So now, if I do this part 2 instead, then we will start entering unreachable code, because this is the loop detection, basically. Loop detection was unreachable before, but now it will be reachable. So in case we have gone in a loop, this means that this vertex that we are in has a loop, right? So loops, so the new loop that we're going to start constructing here is the loop, right? Is the loop. It doesn't matter which direction we go the loop, so like the backward direction is going to be it, I think. So the so I'm going to put the first vertex here. Position is the current position, and indexes is this. But I'm going to say that new loop index. I mean, you know what? Indices, I'm going to make that later, maybe. I think. Yeah, so the index is going to be like constructed later. Let's see. Here's the new loop, and then I do old loop is self loops insert for the position, the new loop. And I'm asserting that this is the only loop because loops should not have been there. The old loop should be none, right? The old loop should be none. And then this is going to be not the solve. This is going to be mark loops. You know, this is going to be mark loops thing for now. So whenever I'm getting from my DFS, I want to know optionally the position that we need to like, which is like the last loop position basically. All right. So if position is the last, over here I return none, whatever, no loop. If we are processing over here, I return the fact that we are looping until the position. So we're going to unwind. I'm going to unwind the loop until I like get back to this position, right? If I am done here, so for now, this is not going to be here then. I'm not getting the actual answer to the problem yet then. So if it's if this has been done already, then this is unreachable actually. Hold on, then this is unreachable, right? Because how can I even come to the same place twice? Well, our graph is now undirected basically, and before it was directed. So for the part one, let's do this. If we are doing part one, then it is going to return none here because no loop has been detected, right? Otherwise, it is actually unreachable because I don't see how it can happen. We are not supposed, yeah, like this cannot happen, literally. Wait, can it? Hold on. I'm unwinding to... Hold on. So like, let's say that I'm on this vertex, right? And I'm doing the DFS, I'm going this way, then I'm doing here. I see that I'm in a loop, I'm going to unwind. I'm going to continue doing this one, and I'm going in that direction. So in this case, it is done, and this is not... Okay, so it's actually reachable, I think. I think we just return none here. Is the thing. Okay, and then we are starting the processing. We are doing all the directions. We don't calculate the result. We just insert the fact that we are done with this vertex in the end. And if it is the forest, then if it is not the forest and not outside of the map, then we do the solving. The mark of the loops from the new position. This is my previous position, right? And the mark loops is a thing must use. This is a thing that gives me the position that we need to go back to in order to like close the loop, basically, right? Yeah, and I need to return something here. And I also need to return something here. So if by going into another vertex, right? Some loop start. If it is here, you want Hamiltonian instead of cactus, maybe? What is Hamiltonian? What? This looks scary. Operator all associated with kinetic energy, potential energy. What? I mean, Hamiltonian graph? Kinetic graph that contains is a path that visits each and every vertex exactly once. No. That doesn't matter. No. Why would I want a Hamiltonian cycle that is a path that visits each and every vertex exactly once? I cannot go to a vertex multiple times. Well, I guess this one, each and every vertex once, exactly once. Like we in our answer are going to not visit some vertices, so it's not exactly once. For some, it's going to be 0. And I'm not going in a loop. But I guess for Hamilton, it can be a path, not a loop. Does not necessarily have to be a loop. Okay, anyway, I did my DFS. I found that we are starting in a loop, right? And I want to see if I marked a loop, right? Let me also make sure that every vertex is a part of only one loop. Part of loop is going to be a hash set of positions. Can I do that? Part of loop. Just to make sure that it is a cactus, right? Just wait until I write all of this and it's not a cactus, but I'm pretty sure it should be. And that's the reason why your brute force is kind of working, maybe, I think. Loop start. I have found the loop start, right? So I do self part of loop. I'm going to insert the current position. We are part of the loop. And I'm going to assert that I have inserted a new element here, right? Insert returns true on the first insertion, right? So this position has been part of only one loop that I have found here. Let me get rid of the red highlight here. Okay, so we have the loop start. We are part of the loop, and I'm going to the loops for the loop start. This is where we are actually storing the loop in the vertex that is was like the first that we found to be looping. This loop positions, I'm going to push the current position, right? The loop is this one. I'm pushing this, but only if position is not equal to the loop start. Yo, Cakes, hello there. Thank you for the raid, bro. Thanks. I'm doing Advent of Code again and not working on my part game. I'm sorry, and not working on the other game that I'm working on also. No game development today, but thanks for the raid. We're doing Advent of Code day 23, part 2 right now. In case anyone is wondering. Think Cider is cancelled? No, it's not. No, it's not. We're going to work a lot on it soon. Alright? Soon. Soon TM, yes. Get mute, loop start. Like that. Okay, so we have found the loop. If the position is equal to the loop start, then it means that I have closed the loop basically. Right? It means that I have closed the loop. Otherwise, I'm pushing the current position into the loop. So if I have closed the loop, then I can make the indices. So I'm going to do for index and position in the loop positions. I'm going to like construct the index so it's fast. The loop index, insert for the position, the index, okay? First position here. I need to have the copied here. Okay, and then loop start that we are detecting here is starting with none. And if I have not closed the loop, in that case, the loop start is going to be equal the thing that we're going to return, you know? Let's just call it result. Result is some loop start. Result replace the loop start. And I should have replaced none. Let me assert. Let me put more assertions in my code. Visited insert. Okay, and now I return the result here. Okay, I'm pretty sure that what we did here is if our graph is actually a cactus, then I'm going to mark all the loops and construct the indices here, right? So let's do mark the loops from the entrance, and the previous position is none, right? And this should end up being none because I should end up with returning nothing. Let's put another assert here. Okay, let's see. Assertion failed, part of loop, insert position. Okay, amazing. Position. Let me see. So this is the example, 1121. 11, this, so actually 12 and 21, which actually is 22. Over here, I have been here, right? this looks like the closing of the loop. And I have found it. I want to actually draw this graph. Can I draw this graph? Hold on. Can I draw this one? Let's make it go here. Let's make it go here. So we go down. Ah, shit. We go down, right? Down this. 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 I think it's easier. Hold on. I think it's easier if I do a screenshot. Okay. Let's do this here. Here's our graph. I want to see it a little more clearly. Okay, well, I already see it here. I already see. You see this loop and this loop. This is different. Okay. Okay, it's not a cactus. All right, let's figure out something else. But as you can see, this is a map, right? And when you have a graph on a map, this is called a planar graph. Then we that's what we have, planar graph. If you know what this means, it means that you can make it, you can draw it so that no two edges are intersecting, and there is some specific like properties about graphs like that too. Okay, I have a planar graph. How do I find the closest thing, the longest thing though? I don't know. Maybe it's because, like, I don't know. Well, I mean, if you take a look at this one, hold on. If I take a look at this one, hold on. If I take a look at this graph, then it's basically something like this. From what I see, okay? That's what we have. Maybe that's the type of graph that we have. Maybe we have a grid. Maybe we have a grid. And we start in the top left and we go into the bottom right. Is that the graph that we have? I wish there were Twitch chat spoiler messages. Yeah, that's interesting. But then how do I know if I should ban someone or not if the messages are hidden from me? Okay. Like, let's say that this is something that we actually have, even though I need to check it first too. I should have probably done this drawing myself before writing the code for detecting the loops and shit. Let's say that we have a grid like that. In that case, like, in that case, Rod 13. All right. If I have a thing like this, there is still how do I find the longest path here? Because like I can go both. I can make a snake. I can make a snake. Can something other than a snake be the longest path? And also, sometimes we can do it like this instead, right? Sometimes we do these snakes. Sometimes we do these snakes. It really depends on what we have. Depends on the parity of the width and height. No, it doesn't. It depends on the length of this. I'm pretty sure, because like if I want to go like even if we have a thing like this, right? This is the example. I can go this way, or I can go that way. I can also potentially have this, like, can this be the answer? Can we prove that this is not the answer? Because this is always, like, if we have a square, then going like that is always longer than going like this. Is that true? Is that true? These are not actually, these are not actually the straight lines though. So if we draw something like this, I mean, I still need to go like around, so it is at least, I mean, I want to find the longest one. Yeah, okay, hold on. It can be, right? It can be that it can be that I have the direct path like long like this, right? But when I'm going around, I'm just doing this, straight lines, and then in this case, even though this is just like a square, then I would prefer this way instead. Edge lengths can make it longer path. Yes, exactly. That's what I'm talking about. So it's not always like that. There is another part of the input that we have, which... Wait, actually, hold on. No. No. Look at this over here. We have... It's not just a maze that is generated here, because this is not a dot here. Okay. So I want to make the longest path on a graph like this, let's say. What does not make sense to do though? Does it make sense for me to go down to go in the bottom right half, and then after that somehow end up out of the bottom right half? I mean, it does, because I want to make this snake. Hold on. If I have like I was thinking about like dynamic programming here, but I don't see it. how it can be done. This is actually what we have. What if maybe there's not that many possibilities. Maybe there's just not that many possibilities. Like I want to know if this is a grid, then how big is this grid, right? Then how big is this grid? I mean, how many points do I have where I can go different directions? Let's test this thing. Let's test this thing. So I'm going to go for row and for row in 0 to map length, for column in 0 to map 0 length. If map row column is not tile forest, then I want to see how many neighbors do I have. Neighbors is all the directions. I take all the directions and then I filter map them. This is the direction, the x, dy. New row. We call this x and this is y. New x is x as i32 plus dx, and y is y as i32 plus dy. If nx less than 0, return none. If ny less than 0, return none. And I do map get nx get ny. This is tile. And if tile is not the forest, then that is sum 1, sure. Otherwise it's none. So this is the neighbors, and then I calculate the sum of those. So this is the number of neighbors for this one. So if the number of neighbors is more than 2, which means that we can go multiple directions actually. Exactly 2 means that we are like in the middle of a path basically. So there's like 2 neighbors going back path and forward to the path, right? More than 2, that means that we can actually have a split. Splits plus 1. What's the number of splits that we have in this graph? Okay, I have 7 splits. This is in the example, though. This is in the example. What about the actual thing? 34. 34 splits. Which is not that many. Which is not that many. But we cannot just do the full brute force. But maybe we can. Hold on. Maybe I should have just like written a brute force and that's it. So like we don't have that many splits, which means that if I just do a DFS, which in case we basically allow going in the same place twice. If every vertex is connected with everyone, then the complexity of that algorithm would be the factorial of 34. But obviously not everything is connected with everything, right? Obviously not everything is connected. Let's just Control Z until we have our original solution. Let's just Control Z. I should have saved it. Right? Should have saved it. Control Z. Go back. This is the loops. Okay. This is it. Part 1, 2050. Okay. So here's what we're going to do. This is just the DFS, right? But we have I mean, if for example, in every single choice of a direction is one of 4 choices, right? So if we have 34 splits, then I can at least say that my complexity is like, so I can have multiple directions that I can go. So let's say like 3 directions every time for every of those splits. So 3 to the power of 34. And this is the actual complexity, which is still a little bit too much, right? So, but maybe like there is something else about the graph that like we can see. We're not going to choose it on every single direction, right? Because sometimes we're going to hit ourselves. So visited, we literally have visited or not visited the thing, you know? Instead of this being an enum, the loops, we don't have them. Visited is just a hash set of visited positions, all right? Part 1, whatever. Yeah. So basically, if self visited get position, if we are visited, then it means that I'm going to return none. Like I cannot go this way, basically, right? And if we were not visited, then we insert our position into the visited positions, and in the end, after we like go back, we remove ourselves from the visited list, and that's how we do the brute force instead, right? And that's all the changes that I need to do, right? 2050, and then for the part 2 example is going to be 154. That's right, 154. So then for the not example, is it too long? Like how can I see if this is too long or not? But this seems like too simple solution. If I run it in release, do I just wait for like 15 minutes and it's going to be finished? No. Okay, so we just need some heuristic for the brute force then, maybe, right? For example, I want to know the current like the current length, right? Current length is what I can do. I can do the answer, the current answer. Let's do this. Solve. This is going to be hold on. I'm going to rename this to brute. This is not going to return anything, actually. This is not going to return anything. This means that I'm in the end, so I'm just going to update my answer. Self answer is self answer max for the current length. Result. No. I just do the brute force like this by doing current length plus equal 1, current length minus equal 1. There you go. And then over here, so we do this only if we have not visited ourselves, because that's the only thing that we can do. If, right? So I'm going to solve. Solve. I'm finding the entrance. And start the brute on the entrance with the previous position being none. And then I return the answer like that. Right? Answer. Maybe it's optional so that I can unwrap here to make sure that we find the answer actually. It's the same thing. Doesn't matter though. Doesn't matter though. One, 5, 4. Okay, so now that we know the current answer, we can like approximate. Can we potentially improve our answer, right? Can we potentially improve our answer? So the potential improvement is basically the shortest path, kind of, but I'm going to approximate it even further by finding the exit. Let me say that the exit is a position, right? Exit. Find row. So entrance is we find the entrance on the row 0, and exit is we find it on the map length -1. So on the last row, what's wrong? Something is wrong with my syntax here. Have an if. It's not finished. Missing field exit. Exit. None. Meh. Solver new map. Let me do the solver new here. Function new map. So I'm going to just do it here instead. Okay. Both exit and entrance, I'm just going to store it here. So for solve, it's using self entrance then. Okay. So on the brute force, I'm just going to see the potential, like distance to exit is going to be equal to basically position 0 minus self exit 0 absolute value of that plus position 1 minus self exit 1 absolute value. So this is the like distance. I can use the pathfinding here to find the shortest distance because it's going to probably be like higher than this for better approximation. But I say basically if the current length plus distance to exit is going to be... Wait, but this is the shortest one. Hold on. If the shortest one is less than answer, then it doesn't... wait, hold on. How do I even do the thing like that then? So like this is the minimum distance that we will run, right? If it's more than answer, then I have to do it. But if it's less than it does than the current answer, then I don't know. Hold on. I don't even know what to do here. I can before, well, okay, here's what we have. Like a lot of these paths, we are like trying to like do things like that, for example, right? And then we go up, and I know for a fact that I cannot reach. I know for a fact that I cannot reach the exit over here, but I'm still trying all of these paths and a lot of different combinations, right? So maybe that's the thing that I should do. I'm going to like stop if there is no way for me to reach. From the current position. Okay, let me make sure that I have the things that that I can go for. Okay, let's do can go into iterator. I'm going to filter the filter map, the dx dy into this, right? So this is the new position. This means return none. So I cannot go this way. This means return none because I cannot go this way. If it's not forest, then some new position is what I want. So this is all like the neighbors. I'm going to collect it into a vec of positions that, like, this is neighbors, right? For new position in neighbors, I'm going to do this, right? And here's what I'm going to do also. I'm going to check the destination only if the neighbor, wait, hold on. Should check reachability only if we were on a split, basically. So if the number of neighbors is more than 1. This is the number of neighbors excluding the previous position. So more than 1 means that we can split both ways, right? So in that case, I'm going to check for reachability. So my over here should check for reachability. I mean, let me just yeah, sure. Let's do this. If I should check for reachability, then let's do this. Self check reachability from the new position into the exit, and if we fail, then I ignore this path completely, right? If statement can be collapsed. If should check and it is not. Yeah, sure. Generate the method. Check reachability self new position. Yes. From the position, this returns a boolean. So over here, I'm just going to do a regular like BFS, I guess, right? I have the position here, and visited is hash set new. Check reachability. Yes. Hash set from iterator, just the position. Okay, so while let some position is keep up front. Let me expand this into a method, self neighbors for the position. Neighbors for the position. It's going to be a vec of other positions. So we can go in these directions and everything. So I'm going to use it. And I need the previous two here, right? For the BFS here, the previous one, it should not matter though. So we do for next in the neighbors of the position. The previous doesn't really matter. I say that if we have not visited it yet, the next, then we insert it, and then we put it into the queue. I don't even need this to be a vectag. It doesn't really matter. Would use a regular stack. Well, I'm not finding the shortest path. I'm just checking for the reachability here. And then I'm going to return false, but if position is equal to the exit, then I return true. Right? Okay. Oh, wait, hold on. I should also, like, it's obviously, right now everything is reachable, right? But I should check the reachability based on whether or not, like, I should not go over the already visited paths, basically, here. So if not visited, and not self-visited. So this visited is just like for like me calculating the reachability, and this is actually my current path. Both of them should be false. That is still very slow. Do I just wait? Hold on. Like, if I'm not checking all of the possible combinations here. I don't know. I can also run it for a little bit of time, do some RNG. Hopefully we find the very long one. It's another possibility that I can do. Am I actually like getting over here? At least sometimes? Yeah, I do. Okay, it's nice. So this doesn't help. I could just make it be faster by like compressing my graph. Maybe that's the thing that I should be doing. If I just compress my graph, then it will work a lot faster, right? Like checking the reachability and everything. Okay, well let me construct the actual graph then. Graph. So it's going to be a directed weighted graph, right? Right. There's going to be a hash map from a position into a list of edges, and an edge is into the position with the length of that, right? So I need to construct the graph here. Okay. So graph, I'm going to start okay. I'm going to start with an empty one. I'm going to go over the x in 0 to map length. I'm going to go for y in 0 to map x length. Position is x and y. If position is equal to entrance, or position is equal to exit, or position is equal to exit, or the number of neighbors, then it's like or the number of neighbors is more than 3, like I was doing before, is more than 2, then insert for the position an empty list, and then I'm going to do like a df pass or something from everyone. And position is entrance. So let's find the neighbors. Neighbors of the position. Let's see. Neighbors for the position is going to return a list of other positions. So this is like on the original graph, right? This is on the original graph. Goal City. All right. Thanks. I guess. I don't know. So if part 1, then shit. Okay, get tile is going to be not a method anymore. Moscow. Yo, 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 yo. Thanks for the raid. Drop? As in like STD mem drop? Cow raid? Like in STD... Wait, where is the cow? STD borrow cow? Like in STD borrow cow? Right. You prefer beef lean cow? Is that an actual thing? Faster, more compact implementation of cow? Wait, hold on. What's wrong with the standard one? What's wrong with the standard one? It's a white cow. Hold on. How's a white cow? Oh, there's a white cow and there's a lean cow. Wait, what? And there's a generic. Faster 2-word cow. This version is available only on 64-bit architecture. Wait, what? Cow. Create generic cow. How does it work? Wait, what? All right. I'm busy solving the advent of code though. But thanks for the raid. Expects the stuff in less bytes. how much less bytes can you have? If it's an own, then you need to store the value itself, and then in addition to the value, you want to know that it is the value. So you need to like have one more byte there, unless that value like is a specific. So like the discrimination optimization, I think is only in the Rust compiler itself. You cannot do this manually, no? Or is it based on what? Puts the ownership tag in capacity. Wait, what is? Oh, wait, hold on. Is it? Wait, in the capacity? Capacity of what? Cow, the reference to string is 24. Well, because it's 16 bytes for a reference to a string. And then it should be 17. Yeah, it's 3 pointer wide. I see. Store in length, capacity, and ownership tag in all one word. So this is only implemented for specific types then though, right? It cannot be for all the types. Capacity and length is not about like is not a thing in every single type. But I don't see any generic things there. Why don't I see in the documentation the the trait or something? Oh, there you go. U capacity. There you go. This type is using generic capacity, which is probably like an unsafe or something thing, right? And it depends on the implementation of the Rust standard library then, which means that it can break eventually in case Rust standard library changes the implementation. Is that right? The capacity is even like I cannot even click on that. Unsafe. There you go. I knew it. Looks stable to you, the implementation of the Rust standard library, but I don't know what's the implementation of a string in the Rust standard library. Like a reordering of the things can happen, for example, right? Ref from parts. Reordering of the fields can happen potentially, for example, in a string or in a vec. Reordering one change stuff here? Well, I guess. Okay, sure. If their implementation is good, then it's good. But I'm a little doubting there. But probably they thought about it more than I did for 5 seconds here. All right, time to solve this here. They have a stable API which gives you capacity into raw parts. Oh, okay. It's an unsafe stable API then, right? Or I just don't use unstable usually. I mean, I just don't use unsafe things at all. Into raw parts from raw parts is not. Yeah, I mean, it makes sense. Into raw parts only gives you the pointers. Makes sense. Get tile position. Neighbors. We can have these directions. Get tile for the position. Sure. Over here I can unwrap actually. Okay, so the neighbors are can go further map. We don't have the previous one here. Get tile is from forest, and then the new position. So this is the neighbors of the position. So I initialize the vertices of my graph here. And now I need to find all the things that are reachable from there, right? So basically for vertex in the graph keys, which is the actual vertices, right? I guess I can do for vertex and edges in MuG. I can just do this, right? So edges is something that I need to like construct here. Okay. Yeah. So I do another like BFS here, for example. I start the BFS from the vertex if position is an important one. So if... Oh, but I cannot see it here, right? Interesting. Position. This is the important. Important is a set of important positions, basically, that that I want to know. Graph is a hash map new. Over here I go then for vertex in important ones to actually construct the graph. I see an add is used for pointers. No, it's not. It's used for references in Rust, and over here it's used for an end. True. No, true. Hold on. We do the neighbors of the position if it is not visited. Then we go there, right? But if this one is important, if position is not the original vertex and it is important, then we found an edge. So into the graph, edges, push the edge. Oh, I need the distance here. In the distances then. So it's going to be not a hash set, it's going to be a hash map from position into the distance. I start with 0 distance here. So we are going to find the current distance. Is distance for the position. So if distance does not contain, then I insert the current distance plus 1 here. So over here I construct the edge. The edge with the length of the current distance, and the vertex that we're going to is this position. Okay, and then we do graph insert for this, the edges. So we have constructed the graph this way. (172) line isn't function a bit lengthy for maintenance? I'm not going to maintain this code, that's first. I mean, I guess I could. Okay, sure, let's do this. Let's put this code outside of this function. Is that better? There you go. It's a struct and a couple of methods on that struct. Okay. This can be split into multiple separate methods too, whatever. I'm not going to maintain the code anyway. We are just solving the thing here. The advent of code. Oh, it doesn't work because I need to move my position and the tile. Also outside, sure. So I have constructed a compressed graph basically here, right? I have basically a compressed graph. And when I'm doing the solving here now, I'm starting from the entrance. So the neighbors is going to give me the list of edges, which I already have. So I actually will get rid of this method completely. Slope. Going to slope. This is something that I don't need at all, I think. Neighbors is self neighbors, so it's not the neighbors. Neighbors is just self graph for the position. Basically, this is the edges of the graph, right? So I'm going to check the reachability. For edge in edges with current length, we add not one now, we add the entire edge length. What do loop do in Rust in the same that for and while? Loop is just while true basically that you write, but while true makes a little less sense, because why do you need to write true if you can just write a loop? Also, it has a little bit of a special thing because like the compiler knows that there is no condition there, so that the entire block, the entire like a loop can have a value that you can break. When you're breaking from the loop, you can give it a value basically. Developing good habits in code is a good practice. Also, you do it usually like after you come up with a solution. We're like trying different things. We're prototyping basically. When you're prototyping, you are not like extracting things into methods to make them shorter. Sometimes it hurts. Sometimes it hurts doing it too early. It's like the premature optimizations are bad, and same is premature refactoring, in my opinion. But it's good to develop good habits to write fast code and to write well structured code too, I guess. Rust does have a REPL. Yeah, Rust does not have a REPL. Okay, so check reachability. Over here, edge.to is what I want. Over here, we brute force from the edge too. So for the reachability, we have the reachability on a much smaller graph, which is just self graph of the position, iterate, map, edge. I mean, let's just do this. For edge over here, next is edge 2. I don't even like that. I just do edge 2 here directly. There you go. I'm not even sure if what I have written here is good or not. Probably not going to work. It's just an optimization that I did right now, which probably is not good enough. Important if neighbors, a length is more than 2. Okay, let me see. Oh, okay, so now because of the edges, I need to clone the edges because I'm mutating self. Alright, sure. In order for the cloning to be faster, I can make this an arc. An arc. Have a slice to an edge. List. Like this. Edges into. Arc slice? Yeah, it's just like an arced string. A slice? No? I guess the only problem with arced slices is that you cannot iterate over them without doing an ampersand and a star. I guess. Which is okay. Arc edge is not an iterator, yeah. I need to do like this here. Slice pattern. Okay. Example. Okay, now nothing works. Now nothing works. Hold on. I broke something. What is this? Contains key followed by the insert. If we didn't contain the key, yeah, try this. No. Hold on. If the vacant entry, then we insert there. Sure. Doesn't really matter though. Okay. Now, what even have I written? Nothing works. Nothing works. Allow flippy range needless range loop. Is this the one that I hate, that I don't like? What else do we have here? Let me try debugging the graph. Debug the graph. Edge cannot be... yeah, sure. Let me make sure that the edge is debuggable. And for the debugging, I need You take a reference there. Okay, it looks like I'm not even constructing the graph. So the bug is over here. The bug is over here. I have a while. I have a neighbors. Let me do here debug v. Not sure where am I going here right now. Okay, so I got to one of the vertices and then 22, 21 specifically in the example, 22, 21. So actually to the exit is where I got. And I cannot do anything about the exit. For some reason. Neighbors. Debug position. We have the position, which we go into the negative directions, which does not matter. Which I mean, which means that the edges are the neighbors over here are not correct. That's what it means. The neighbors can go outside of the map. I need to okay, let's match get tile at the new position. And if it is some tile forest, then none. Or if it's none, then none. Otherwise, we return the new position here. So we cannot go into the forest and we cannot go outside of the map. But other than that, we can go. Right? Okay, there you go. The answer 154. Okay, it works. It works. I have constructed the graph. Let's try running it. Actually, is it like for whatever reason now working? Looks like it is still too long. Let's debug the graph length. So this is the number of vertices. The number of vertices. Wait, hold on. What? The number of vertices is 1050. Did I not check before that the number of splits is like 35 or something? No? Did I do it incorrectly here? What are the important ones here? Let's do graph keys collect into the back. Let's debug that. 9010, for example, right? Let's check line number 91. Number 10 is this. Number 10, hold on. 10, 11. Wait, hold on, what? 9010. That's wrong. Oh, I see. I see, but it doesn't really matter. It's because some of the forest is also considered an important vertex. So let me do if map xy is the forest, then I continue because I don't want the forest to be an important one. Okay. The size of the graph now is 36. Okay, we have 36 vertices in our graph, right? Checking the reachability. So this does not help much. Okay, why did I do it then? Why did I do it then? We need to think more. I need to think more. But I do have a compressed graph, which seems to give me the proper answer to the examples. Okay. Well, 36, you say. Like, if it is like this, I still don't know what to do. Still don't know what to do. It's only about 1.3 million ways. Are you saying that just my code is slow? And my brute force is incorrect? I'm checking for the reachability, so I should be... Check for the reachability is if I have at least one edge. Oh, I should check for the reachability if the number of edges is more than 2, because that's all the outgoing edges. Maybe that is the thing. Because I was skipping the going back before, and now I'm not. No, there's... Wait, hold on. It actually has calculated it. Okay, so it means that just my code is a little bit... too slow, because I think it should have been calculated in less than a second, right? This is the right answer. How would I improve it though? It's just like going over all the possible ways. Check the reachability. I just check for the reachability to the exit when I'm like going through a split. If it's 1.3 million ways, it should have ran a lot faster. Maybe I should not even check for the reachability, and then it's going to be even quicker. No, it's not. I mean, it doesn't matter. Checking for reachability does not matter. This is still very, very fast, so I can delete that. I can delete that. It doesn't matter. But still, if I time it, then my program currently runs for 5 seconds. Let's calculate the number of ways actually. Self ways plus equal 1. Ways is this. Ways 0. So when I'm doing the solving, I'm going to debug the number of ways that I have calculated. Let's see what it is. Let's see what the number of ways actually is. 1.3 million. Yeah, it is 1.3 million. Why does it run for so small amount of time? Because I'm not skipping a lot of the ways still. Okay, anyway, we have solved this. Is day 23 of Advent of Code, and I have 2 more to solve. Are the next one's harder or easier? Oh, I have 2 more days to do. 24 and 25. I'll go eat though. I'll go take a break for like 5 minutes to eat. Very healthy food. Yes, indeed. That's what I'm eating. Okay. J24 is heavy math. All right. I'll see it after I come back. I am back. Okay, guys. Let's see. Let's see how heavy is the heavy math. Why is it math here? Is this called advent of code? It should be code, not math, right? Maybe some math problems can actually be solved using code, though, right? Let's see. Never tell me the odds. It seems like something is going wrong with snow making process. Instead of forming snow, the water hasn't been absorbed into. Instead of forming snow, the water that has been absorbed into the air seems to be forming hail. What's hail? Maybe there's something you can do to break up the hailstones. Due to strong probably magical winds, the hailstones are all flying through the air in perfectly linear trajectories. You make a note of each hailstone's positions and velocity. Okay. Each line of text corresponds to the position and velocity of a single hailstone. The positions indicate where the hailstones are right now. The velocities are constant and indicate exactly how far in 1 nanosecond. Each line of text uses the format. Okay, perhaps you won't have to do anything. How likely are the hailstones to collide with each other and smash into tiny ice crystals? To estimate this, consider only the x and y axis. Ignore the z. Looking forward in time, how many of the hailstones paths will intersect? How many of the hailstones paths will intersect within a test area? The hailstones themselves don't have to collide. Just test for intersections between the paths they will trace. In this example, look for intersections that happen with an x and y position, each at least 7 and at most 27. In your actual data, you'll need to check a much larger test area. Why is it 7 and 27? Comparing all pairs of hailstones' future paths produce the following result. This path will cross inside the test area. Okay. So in this example, okay. However, you'll need to search much larger test area. You want to see it? Okay. Party 1 is pretty relaxed on the math. Okay, let's see. It seems like it's easy so far. I mean, though, instead of writing a vec from scratch, like always, let me do cargo add. I'm going to use my own library for that, badbox LA. This is the linear algebra, which is not much. Just the vecs. Okay, then 24. Example is this stuff. And then we have the search area. Disregard the z-axis entirely. Okay. Let me make sure that the input is also downloaded. Day 24 input. Okay. So let's read the input. Let's use the linear algebra stuff. So here's what we have. We have quaternions, which I'm rarely using, angles, axis line bounding boxes, matrices, and vecs. But I only need the vecs here. I'll use a star though. Okay. Let's see. So we read the input, which is hailstones, right? Hailstones is vec of hailstone. Hailstone as a position. the integer one, right? And the velocity. Like this. So I'm going to do input lines. For every line, I'm going to make a hailstone. So position and velocity is line split once using space at space, right? And then position is let me do this. Bars for a string which gives me a vec3 is going to be as split using space comma, and I map that into parse unwrap. This is going to be a vec, right? But then I do xyz, which is exactly 3 of those, is this try into, and then I do vec3 xyz. Okay, there you go. So position is parse position, and velocity is parse velocity, and we have a hailstone with position and velocity, right? As a result, this needs to be collected. All right, there you go. So this is the hailstones. Let's see that I have read the input cargo run day 24 part 1 example. Okay, parse int error invalid digit though. We have an invalid digit. Wait, hold on. There's 2 spaces here? Oh no. There's 2 spaces. Look at this. Who decided to do that? Alright, fine. I will trim it before splitting then, sure. And in that case, I don't need to have spaces around the comma and the add symbol. Okay, then I can read the input. Nice. So now that I have these, I'm going to only use the 2D coordinates, right? I need the search area though, right? I need the search area. Let's see. Search area is if example. So for the example, I'm going to use what? 2 to 7? What was it? Boundaries of the test area. What's the test area for the example? 7 and 27. Okay. Search area is 7 to 27. But if it's not the example, then it's going to be this to this, right? Audit didn't panic on such large numbers. This is large, but this is out of range of the I-32. But I guess the velocities themselves. Well, hold on. Yeah, you're right. Why did it not panic? Why did it not panic? Oh, because I was running on the example. If I run it on the actual input, then range inclusive of I64, sure. If I run it on the actual, then I panic. There you go. Position overflow is what panic we have. So yeah, sure. It should be not I-32, it should be I-64. Now we don't panic when reading the input. I was just running it on the example. Okay. Let me debug the number of hailstones. How many hailstones do I have? I have 300, so I can just do it. Wait. So we just do in pairs, right? And just see if they are intersecting, and if they are intersecting inside, then I add it to the answer, right? Is that it? Am I reading this properly? For A and B in hailstones, iterate pairs, permutations. No, not permutations. Isn't there in itertools a way to iterate over the pairs? Tuples. Tuples? Return an iterator that groups the items in tuples of specific size. So 1 to 5 tuples is 1, 2, and 3, 4. Okay, no, this is like the chunks. Choose. This is from random crate. I don't want the RNG, right? I don't remember. I don't use this usually, this crate. Cycle, no. Duplicates, dropping. Let me just see this here. Rust, itertools, pairs. I'm pretty sure there's combinations. It's called combinations. Combinations is an iterator adapter that iterates over k-length combinations of the elements from the iterator. So you can do not only pairs, but any combinations, basically. But can I do tuple combinations? If I do tuple combinations, then it's going to be even better, because I can do literally A and B here. There you go. So we have a pair of hailstones, basically, here. I wish there was like a method that's just called pairs, though. But sure. This is the pairs. I need to see if they intersect or not. So let's see. Position 1 is A position. I'm going to ignore the Z, right? I'm going to ignore the Z. I'm going to solve this using F6 I guess. Pairs might be confused with windows. Well, there is a method that's called tuples, which is the windows. Wait, but there is tuple windows. Tuples regular is the chunks. There is a chunks in the Rust std. I don't know. No, window, I don't know. Why, like, okay, I guess true, but at the same time, can they then remove the tuples? Because this does not say what kind of tuples this is. This should be like tuple chunks instead, I think, to mirror the std chunks. Map. Okay, so there you go. We have let's see this. We are basically going to convert vec3 i32 into vec3 f64. I guess it's not i6, it's an I. Right? Let's see. P1 is A position. V1 is A velocity. V2 is B position. V2 is B velocity. Well, this thing that they try to do this here, like, I mean, technically I can do it in integers, but whatever. I'll just use the floating point numbers. It should be fine, right? Unless there is going to be like actual problems with the Well, I mean, technically there might be. Like, if they... actually, no, it's not. Like, the velocities are not that big. The velocities are not that big, so the problems with the precision should not be here, I think. Just the positions are like that. Are the positions all inside the test area? I don't know. Whatever. So we don't care about the Z, and we use F6 force here. So here's the actual, like, math behind this, right? So the trajectory of the first one is P1 plus V1 multiplied by T, right? And then there's also the equation for the point to line on a line. This means that point minus some other point on the line, and the like this skew product of this and the line direction, or the dot product with the normal, is going to be equal to 0. So we just need to find the time of intersection basically here. So this means basically that skew product of P1 plus V1 multiplied by T minus P2 by V2 is equal to 0. This is the math. So we can say that skew product of V1 and V2 multiplied by T is equal to skew product of P2 minus P1 and V2, which means that T is skew P2 minus P1 by V2 divided by skew product of V1 and V2. So the skew product is going to be equal to 0 if they are parallel to each other, though, right? So I need to see if this is equal to 0, which should be okay. I mean, you know what? Let's have them still be in integers. You know, P1 is a position. I just ignore the z coordinate here. So the only thing that when we are doing the division, the only thing is that when we are doing the division, we should check that it's not 0, and we should convert to floating point numbers when doing the division, actually. So the point of intersection is going to be this, right? And I can convert them to floating point here. And then I check if this is inside the test area. It's called test area, not search area, right? So I can do test area is the start. This is the thing. Isn't division by 0 defined for floating point? Yes, of course it's defined, but it's going to be none. I don't want to be working with nuns. Position. So yeah, basically over here, I just say if test area. Let me make test area also the floating point number, whatever. So if test area contains the intersection point, then we add it to the answer, right? A and B. This is B. Okay. For the example, the answer that I have found is 5. So why is that? Probably because I need to see paths are parallel will never intersect. Paths crossed in the past for Hailstone A. So like in the past should not be right. 1, 2, 3. Yeah, I'm calculating the things in the past. You got the same answer than you did this? Because I thought like they said intersect the line. So like paths is array, not a line. I was just assuming that they were like saying the full lines. But yeah, the way I do this is let me do this here. So I'm going to have a function that's called intersection time. So the time is positive, means in the future, negative means in the past, right? So P1, V1, V2, V2, right? This is going to return the time. The time is going to be optional, actually. So we just move this. We just move this over here. Over here we return none because they don't intersect, basically. Over here I return this, right? Yeah. So time for the first one is going to be intersect v1, v1, p2, v2, right? They should be intersecting. Otherwise we ignore. And then let T2 is intersect. So we just over here we switch who is the first one, because this solves it for the first ray, basically. So if T1 is less than 0 or T2 is less than 0, then I continue, because this is in the past, right? Over here I can unwrap because I already checked the intersect, so it should be there for sure. So yeah, that's it. So the answer is 2 now. And then we run it on the actual input, and the answer is this. This is the right answer. Let's continue to part 2. Upon further analysis, it doesn't seem like any hailstones will naturally collide. It's up for you to fix that. You find a rock on the ground nearby. While it seems extremely unlikely, if you throw it just right, you should be able to hit every hailstone in a single throw. You can use the probably magical winds to reach any integer position you like and to propel the rock at any integer velocity, now including the z-axis and your calculations. If you throw the rock at time 0, where do you need to be so that the rock perfectly glides with every hailstone? Due to probably magical inertia, the rock won't slow down or change direction when it glides with a hailstone. In the example above, you can achieve this by moving to position this and throwing the rock there. If you do this, you will hit every hailstone as possible, as follows. Any integer. I need to hit every rock. Does it collide if the time of collision is correct? Each hailstone is identified by its initial position and velocity. Then the time position of the hailstone collision with the rock are given. After 1 nanosecond, the rock has exactly the same position as one of the hailstones. Another hailstone is smashed 2 nanoseconds after that. So this after 1 is exactly 21, 14, and 12. Okay. Determine the exact position and velocity the rock needs to have at time 0 so that it perfectly collides with every hailstone. Wait. So it's not always possible though, is it? So it means that for our input it is possible, right? Well, let's see. So in order for, like, if we have just one rock, then we can just place ourselves in the very beginning on top of that rock, and that's it, right? If we have 2 hailstones, one is going there and another one is going here, right? Then I can go from the start of this to wherever this one is, and like I need to like make sure that I intersect them, right? Right. And then if I want to collide with the third one, then it means that I just need to check if I will intersect or not, if I will hit it or not, because I cannot change anything else here, right? I cannot change anything else here. So basically the solution then is to figure out the pair of the original ones and then just check that that I'm hitting everything. It seems the only other thing to consider is that potentially I can initially place the rock not on top of one of the hailstones, but somewhere outside of the hailstones. And in that case, we do something else. But let's first see if I can start in the beginning on top of one of the hailstones. Then, like, I should be good, right? So this is part 1. If part 1, then we do this. Otherwise, this is part 2. Part 2. So I'm going to go over the pairs again. And hailstones, iterate, combination, tuples. Right? So A is the first one. Wait, tuple combinations. But it matters which one is first and which one is second. It matters which one is first and which one is second. Whatever, I can do something like this. For I in 0 to hailstones length, for J in 0 to hailstones length, right? I make sure that they are different, right? And A is hailstones and B is hailstones J. So basically I start at A and then I shoot at B, okay? And then I shoot at B. Okay, continue. Let's call this just array, I think, because I'm going to use that for myself too. So rock is going to be array, which starts from the A position, right? So that I hit the rock A. And then the velocity of the rock is so that we hit the B, basically, right? From the A position. Let's see. How do I figure out what it is? Unreachable code. No such field from its position. Okay. Let me see. So we should do something like a position plus velocity that I don't know about multiplied by t should be equal to b position plus velocity multiplied by t, right? So we have the three unknowns and we have three equations because this is three coordinates. Wait, hold on, we have four unknowns. The time and then the velocity itself. Okay, I see. Hold on. There's multiple ways for me to throw a rock to hit the second one, right? I can basically hit it at any time. And then I choose my velocity to get to the position in this time, basically. Any time except for 0, I guess, is okay. So this means that I need to... Hold on, how many do I have? Of the hailstones again? How many of the hailstones do I have again? I forget. $300. So if I do 300 to the third power, it's going to be pretty okay. But if I do it to the fourth power, then it will run for too long, I'm pretty sure. So I need to do a cubic algorithm here, right? So I need to check. So I need to have three. I need to choose 3 hailstones. I place my rock in the start of the first one, and then I need to hit 2 of those, right? And in order to hit 2 of those, I will have just one solution, maybe. Oh, or maybe. Hold on. Or maybe. Or maybe. Let's see. If I need to hit just one of them, right? Then where can I place my rock? And what speed should I have? This is 6 like things. So I can place it. I like, if we consider this space, the hyperspace with 6 dimensions, or 3 dimensions of the positions and 3 positions of the velocity, then we have what? Should relax from coding? I will relax after I solve all the advent of code, I guess. I guess. Okay, well, technically it's a 4-dimensional space, I'm pretty sure, because it's the position and the time, and by the starting position and the time at which hit that rock. How many time are you on advent of code? What do you mean, how many time? How many times have I done it? This is my, I did the advent of code. This is my first one that I'm like doing to the full. I only have 12 stars in 2021 before. If I have The longest day of advent of code was? What do you mean? The longest day of advent of code was? Every day is 24 hours. No? I'm not sure what exactly are you asking? What is the longest time I spend on solving one day of advent of code? Or how like today I'm spending 7.5 hours just streaming advent of code, and is this the longest one or is it not? To solve the day? I don't know. I think 2 hours max time to solve one day, I think, is what I had so far. I think maybe 3 hours. Every day you take 2 hours to solve one day of advent of code, I guess? No, that's not right. With one hailstone to hit, you could start anywhere by setting your velocity to hit at the time you want. Yes, exactly. That's what I said. That's what I said. Some days of advent of code are harder than the other ones, so we take more hours for some of the days, and we use less hours for some of the days. Some of them took 5 minutes. Bye, thanks for the stream. Bye. Okay, let me think if I want to hit both. If I want to hit both, then it still is wrong. Still is hard, I think. It's not... Like I can start... If I start in the beginning, then for the second one... So, okay, so let's say that the position is fixed. And the position of the beginning is going to be in the start of one of the hailstones. I still don't know how to prove it, but that's what they have in the example. So that's the intuition. For the start of the rock, we are going to choose one of the hailstones. And then our velocity is going to be... So based on the time to hit the next one, right? Let me see. So if I have here's what we have: a position plus whatever velocity we choose multiplied by t is equal to b position plus b velocity multiplied by t, right? So this is the unknown, and this is the unknown. Right? So I can say that velocity is equal to b position plus b velocity multiplied by t minus a position, and all of that we divide by t. Would you mind? Ask ChatGPT. No, you can try if you want. I don't care about what they say. So as you can see over here, we can choose any time we want to hit the second hailstone still. So we can say that velocity is velocity is let me see, b velocity plus b position minus a position divided by t. right? And this is anything. This is basically anything, which means that for me to hit the second rock, to hit the second hailstone, my velocity basically needs to be any point on array. Okay, there you go. There you go. So now we convert every single other hailstone into array of the possible velocities that we can choose. All right. And this is our new ray for the new velocity. It's has the start at that velocity and then over there. And now I need to find the intersection of all the rays of possible velocities for all the other hailstones. I don't believe programmers use their brain to solve problems anymore. You can try asking ChatGPT if it can solve this one. Yeah, sure, do it. Do it. Maybe I don't know. I don't know if it can, but I'm pretty sure that it should not be able to solve this one. There was a thing on Codeforces. There was a test. Someone has trained an AI model to solve Codeforces problems, and then when it couldn't solve all the problems of the competitive programming, but it could solve it like on some level. And then when people saw the actual solutions of this thing, then it turned out that the solutions were like a copy of the solutions of some other participants. But that's not because that's like the only way to write that code. Like it was pretty much stealing the solutions because it found it on the internet. It didn't even come up with the solutions itself, is what people figured out. And even then, it could not solve the hard problem. So like it was a better than like a newbie programmer, but it's not very good anyway. Okay, here's what we're going to do. I'm going to see start. The start is going to be my hailstones. Positions, right? So these are all the hailstones that this is all the potential starts that I'm going to consider, right? And then velocity rays is going to be hailstones iterate map. So in order to hit this hailstone, we are doing this here, right? So my start plus my velocity multiplied by t should be equal to, this is stone, right? So a position is start. So there you go. I'm going to convert. This is the possible array, right? So it's array with position equal to this stone's velocity, and velocity equal to stone position minus start. Okay, there you go. There you go. So we have the velocity rays and we need to intersect them all. And if they intersect anywhere, then it means that this is our like velocity that we need to do. Okay. So now I just need to intersect 3D rays in comparison to 3D rays. Right? Now in order to intersect the 3D rays, let me try and see. It's going to be like similar. It's going to be really similar. It's going to be really similar to over here. So I'm going to do for A and B. Wait, hold on. If they intersect, they intersect in just one point anyway, right? So I just need to find the intersections of the first two and then just check the other ones. Right? Yeah, that's right. But for some of them, the velocity is 0. Don't position minus start. Wait, hold on. Yeah. So let's see. So here's what happens over here. If I want to collide with the first, with the hailstone that I decided to choose as my start, then it means that its position and start is the same, which means that my velocity is just exactly the stone velocity, right? Because it's like, I guess only if it's not equal. So I need to filter map here, okay? And to filter map, stone position if it's not equal to start, because if it's equal to start, then like, yeah. So then some ray, there you go. This is the filter map. So now all the rays are not 0 velocity, and I need to intersect them. There you go. So I intersect the there can be some parallel ones still, technically, right? So I need to find a pair that does intersect. So let's see. We do the velocity rays. We do the tuple combinations. So this is the intersection point. Wait, there is no test area, right? In the second part, there is no test area. Okay, the test area is only about the first part anyway. So the tuple combinations, this must be clonable. So I need to be able to clone my arrays. In fact, I'm going to be able to both clone and copy and debug. Tuple combinations. So I'm going to find the one tuple where these rays are actually intersecting, and this is going to be the intersection point, right? Yeah. So let's do the same. Let's do the same as here, kind of, but not really. Intersection time is for ray 1 and ray 2. So intersection time for ray A to hit the line B, basically. Time for ray A to hit line B. This is important here, I guess. So I'm going to find the time to intersect A and B. If they don't intersect, then we continue. And time 2 is we are going to intersect the ray B with the line A. And if any of those is in the past, then means that we did not intersect anything, right? So over here, I can do a question mark. Over here, I'm going to unwrap. Over here, I return none. And then over here, I'm going to return T1. No, not T1. I'm going to return ray I don't only want, oh, not only the intersection point, it's intersection point and time is what I want. By the way, intersection time should be the same, right? Yeah, this is in 3D, which is a little different. Hold on. How do you do the intersections of the rays in 3D? Well, I mean, yeah, no. The time should not be the same. It's the same. It's the same stuff. Yes, it is exactly the same stuff. It is exactly the same stuff. Ray A to heat line B. Yeah, it's still the same, just in 3D now. But they should both be more than 0. Still, yes. And then we return some point, which is going to be a position plus a velocity multiplied by time let me call t1 a time and let me call t2 b time. So I do this. This is the intersection point, and then the time is a wait. Well, I mean, yeah. It's just the intersection point. All I need is the intersection point. I need to check that the intersection point is on the line of is on the on all the rays. Intersection point is all I need. Yeah. So I'm going to unwrap this because it should exist. Okay, now we need to intersect the two rays in 3D, right? So in 3D, what is our... So this is the equation, right? P1 is basically a position. V1 is a velocity. P2 is B position. V2 is B velocity. So instead of a skew product, because it doesn't exist in 3D, right? In order for me to be on a line, it is a cross product. It is a cross product. It is a cross product. There you go. That's the only difference for the 3D. Instead of vec2, it's vec3 cross product. So if anyone knows, the cross product is the multiplying of the lengths is a vector, which length is the multiplication of the length multiplied by the sine of the angle between the two things. So if the angle is 0, then the sine is 0 basically. So for that reason, the cross must be equal to 0, right? But the cross product of two vectors in 3D is obviously a vector itself. So I want to see the length of this, and this should be equal to 0. But it is not correct. It's the square length that I want to do here. Let me extract this. I say that this is cross. Of A velocity and B velocity. So if cross, I'm just doing the dot product of it with itself. If it's equal to 0, it means that Well, I mean, hold on. I can just check if cross product is equal to vec3 0. I can actually do that. Okay. So time is the cross product of this divided by that. Is that right? No, I cannot divide a vector by a vector. So it means that this is denominator and this is numerator, right? So I want basically to find such t where denominator multiplied by t is equal to the numerator, right? So I'm going to divide them, like actually. But I need to make sure that they are the same. Hold on, do I have the division? I do have the division. So this will divide the thing on every single this will divide the thing on every single axis. And then I need to just make sure that they are all the same. Right? So if t if they are all equal, which might not be the case because of the they should be all equal. Check whether all elements compare equal. Yeah, if they are all equal, then sum tx. Right. Is that right? Is that right? Let me do filter map. Intersection point. Yeah, whatever. Let me debug the intersection point. Attempt to multiply with overflow. Okay, I'm overflowing though, is the thing. So I need to Rust backtrace. I mean, I just want to work in floating point numbers here, I guess. Sure. I mean, probably the original cross product is going to be okay. I mean, this is the difference in the positions. And difference in the positions is big numbers. Is the thing. That's where the problem lies. Because the velocities are small here, but the positions are big, and the difference in the positions is also a big number. So when I'm doing the cross product, it's a very big. So I'm wondering if I'm going to have issues with my precision. If I do even the floating point numbers, do I do like something like rationals here? Because that's what I want. And like the big rationals then too. It's probably okay if I use the floating point, but I don't know. Let's see. Sure. Let me do the ray to be the generic over T. So this is ray with ints. Okay. Sure, let me just convert that. A is a map f64, and same for the B. This is going to be so that I can convert between ints and not ints. Map self f impl fn from T into U. This is going to be array U. There's going to be array position is self position map f, and velocity is self velocity map f. And copy. Sure. There you go. So now I don't need to do any mapping here. Right? This equality to 0. I need some precision checks, but okay, let me try. Unwrap or none, because I cannot find a velocity rays that are actually intersecting. It seems. Wait, what? No way. Okay, let's do intersect time of these two things. These two 3D rays. Maybe I'll write a test here or something. Let's do a test. Test intersect time. Assert equals that the intersect time of the ray that starts from okay, let's place a rock over here. So this is my rock. And the velocity of the rock is going to be this. Right? And then I will hit this hailstone, which goes from this place with this velocity. The collision time, intersect time of these two rays should be equal to some 5, right? Because that's what they have there. Collision time is 5. So let's see a test. Cannot test inner items. Wait, really? I cannot test inner items? Okay. Let's just run the test. Let's just run the test here ourselves. This is the test. Just run it. Okay. So as you can see, I have actually found the intersection time of these two rays properly. It is equal to 5. Okay. Part 2 example. I still cannot find the intersection point because I want to find the two rays that are intersecting, right? let me do debug a, b, and a time, right? I cannot because it seems that I am not here. Wait, hold on, what? Hi? Am I there? I am there. I am here. Okay, I am there. Oh, intersect time is a question mark. Yeah, sure. So it always returns none here, is what it means. Always returns none. I'm not looking for intersection between two hailstones. You're trying to determine an array. Yeah, I know. I know. But I'm trying to find the intersection not of the original hailstones, but of the possible velocity choices that I have, which are also rays, apparently. Hold on, maybe there is something wrong here. So it seems like I am getting here, but hold on, maybe there is something wrong here, intersecting two 3D rays. Position plus velocity minus b position and velocity. The cross product should be equal to 0, right? Right, that's right. So you can say that the t is the cross product divided by the other cross product. So I mean, yeah, they should be all equal. Maybe it's because they are almost equal. Like over here, it's 5, 5, 5. So that's okay. But for the example, they are not even remotely close here. Okay, maybe my logic here is incorrect. Hold on, let's see again. So in order for me... If I have chosen the position, right? Oh, wait, hold on. I see it. I see it. So, yeah, okay. It is after 1 nanosecond, the rock has exactly the same position as one of the hailstones. So, yeah. This is the incorrect thing that I have. The assumption that I should start as in the beginning of the hailstones. That is the wrong assumption. I just want, like, I have the solution in case I know where the possible starts are. Okay. I was just thinking about that. One of the collision times is going to be 0. Okay. Let me think a little bit more then. But I have the intersection of the 3D rays, which is good. Velocity. This is only possible if I know the start, right? Um. So maybe I should... Okay, let's do it one more time. Let's do it one more time. Let's say that, like, let's say that I want to hit both ray A and ray B. Both ray A and ray B, right? Which means that so like basically my start now I can still I can still think about, so like if I want to hit both stone A and stone B, right? Then let's say that I know the time at which I hit stone A and the time at which I hit stone B. Right? It gives me two equations like this, right? And it means that I have 6 equations for every of the coordinate. And I have 6 unknowns, which is the start and the velocity, right? If I know the time to hit stone A and hit stone B. So this means that if I know the times, then I can determine the how to throw a rock. But I don't know the times is the thing. I just don't know the times. If I have... if I know only one time... So we're back to nothing again. So like the assumption that I had, I even didn't read the example correctly. I thought that it was after like exactly the same position at the very beginning. If I have just one ray, then we have it's basically a 4-dimensional thing. The position can be anywhere at all. And then depending on the time, of the intersection, depending on the time of intersection, the velocity is basically determined in a form of array. How many of you guys have solved it on your own? Anyone? I'm like trying to see if the space is like not programmatically. You did it in a math program. No. But a math program does it programmatically anyway, right? You solved it by taking ideas from Reddit. Nice. I'll try to do it a little more without taking any ideas. And maybe since it's just day for 24, I will still need to do day 25. So I think I might need to like do it for the other day, like I did day 20. But I hope I come up with a solution in the next half an hour. So here's my thought, though. Here's my thought. Like, imagine the all possible, like, let's say that we're not in 3 dimensions, but in one dimension. Okay, like the simplest possible dimension is 1 dimension, right? So in 1 dimension, on the x we're going to have the position, and on the y we're going to have the velocity, right? So if I need to hit a rock, then what is the shape of all the possible position and velocity in that case? And if it is like a polygon, for example, then I can do polygon intersection in multidimensional space, which is not like impossible. And then I need to find any point inside the intersection of the polygons. But in our case, like, position is basically actually 3 coordinates and velocity is also 3 coordinates. So this is not just a polygon in 2D. It would be like a hyperpolygon in 6-dimensional space instead. So let's solve the 1-dimensional case, right? If I solve the 1-dimensional case, it still is the same, right? It still is the same. Start plus velocity multiplied by t is equal to stone position, hailstone position plus hailstone velocity multiplied by t. The equation is still the same, regardless of how many dimensions we have, right? So what's the possible start and velocity thing here, right? So I have 3 unknowns, which is start, velocity, and time, right? But let's say that we know the time, that we know the start, let's say that we know the start, because start is like the horizontal axis on this here, right? Let's say that we know the start. Then the velocity, which is going to be like just a function that we can draw here, is this divided by t, where t is anything, absolutely anything. Right? So it looks to me that stone velocity is like the hailstone velocity somewhere. So like if we choose the position, then this over here is the hailstone velocity, and then we are going either up or we are going down, and this is basically a semiplane. T is positive, which means that it is a semiplane, right? So then I'm like just and it's a semiplane that in this case is parallel to the one of the axes, but maybe in the multiple dimensions it would not be true. Right? So is it the same? I think it is still the same, right? So we let's say that we know the position. Position can be anything, right? Position can be anything. We still say that velocity is stone velocity plus stone position minus start divided by t. So this is a semiplane, which has this as a normal to the plane, and I need to intersect all of these planes together and find something in the middle, right? I just intersect the semi. It's not the semi-planes, it's the semi, like, whatever 3D thing is. Right? The only thing is, I don't know the start. Wait, hold on. It's dependent on the start, though. It's dependent on the start. Is the thing. So it always starts. Hold on. So it always starts at the stone velocity, and then we always go in the. It always starts in a velocity, and then we have this. Stone position minus start. So hold on. If I say that it is in 2D, let's try visualizing it a little differently. This is in 2D now. This is the velocity x. This is the velocity y. Right? But on the same plane, I'm going to draw my current position, my position that I have chosen. This is the velocity of the hailstone. And this is the start of the hailstone. So I use this vector. So whatever point I choose, which basically means that I can choose any vector at all. I can choose any vector at all, is what it means by choosing the position. But that gives me all the possibilities again. But if I have chosen the position. And no, I'm back to the same thing. I'm back to the same thing. No, I need to somehow like think about the 6 dimensions at the same time, or at least 4 for the 2-dimensional space. Wait, hold on. Let's go back to the 1-dimensional thing, right? It is so the direction is stone position minus start, right? So if the start that I have chosen is less than the hailstone position, then we're going up. So that means that the possible thing is if we have this the hailstone the hailstone position over here, right? Then if we are less than this, then we're going, and this is the hailstone velocity, right? So if we are less than this, then it can be n velocity up there. So like it's this thing, and if it's more, then it's that thing. So is that the all the possible solutions in the one-dimensional case then, right? And then I need to intersect these things together. This is a little weird shape though. It's not even connected to to itself. Pretty weird. Is that correct for the one-dimensional space? Hold on, because I don't like the shape of two disconnected quarters actually. So it's not a semisphere, right? It's not a semi-plane here. In 2 dimensions, it would be like if I have chosen the position, then it is I'm gonna try some ideas. Good luck with this one, and thank you for the stream. Sure. Might need to end here if I don't come up with a solution quick soon. I don't want to look up it. I don't want to look it up. But if nothing is happening on the stream, then there's no reason for me to continue the streaming. I can think about it off stream. I don't like the fact that there's an if here. I don't like the fact that there is an if here, basically, in one-dimensional case. But maybe it's because it's one-dimensional, and in 2 dimensions it's no longer going to be there. So once again, in 2 dimensions, the position is anything. If I know the position, then the velocity is just a ray in a specific dimension, but it doesn't like give me the idea of the shape of the 4-dimensional space. But because we only have like, so like because the position can be anything, the possible velocities are It is so weird because like the number of like freedom, the amount of freedom that we have in like 2 dimensions is only 3, right? Because we choose the start and the time, which gives us 2 dimensions of freedom. And then time, and using time we can like solve the velocity already, right? So because start can be anything, we can add 1 more dimension of freedom. Which is some sort of a 3-dimensional shape. Oh, no, hold on. It's not a 3-dimensional shape. It's 3. It's 3 like 3 things. It's in the wait, hold on, no, that's not true. If I know the time, then I don't know the velocity. No, that's not true. The velocity can still be. Oh my god, I'm so confused. I'm so confused. Well, no. That's true. That's true. If I know the time, then I know the velocity. No, that actually is true. Yes. So we have like 3 freedoms in a 4-dimensional space of start and velocity, right? So, or in a 1-dimensional space, I have 2 dimensions of freedom in a 2-dimensional space, which is why it's like different. Which is why it actually is different from the 1-dimensional is different from 2 dimensions and 3 dimensions. And just like think about it somehow differently, maybe. Some other way to write this equation is probably there. There's probably some way to write this equation in a different way, right? What does it mean for the 2 rays to be intersecting, right? I actually have it here. Don't I actually have it here? No, this is different. I still have the time here. I need to like get rid of time basically, right? I need to get rid of time. Or maybe we think about the like actually 7-dimensional space where the time is also there instead. Let's say that we know the start and the velocity. Let's do this. We know start and we know the velocity. We have two rays. I want to know if they intersect or not, right? We have the equation here for the time, right? Which is something that we already have over here, right? And in order for them, but this is intersection with a line. We want basically over here in order for the two rays to hit each other at exactly the same time, right? That's what we want. We want, here's the missing equation. I almost have it spelled out here. This T1 must be equal to T2. When I'm doing intersection with a line, I'm not actually like thinking about it, right? But this is the missing equation. So intersect time gives me like that. Look at this over here. T is equal to cross B position minus A position and B velocity, right? Divided by cross of A velocity, B velocity. This is the thing. This is the thing. And in order for this time to be equal to the time of the other one hitting it, right? If I do this, and then we say at the same time that this should be equal to the time hitting the other direction, which means that I just switch A to B and B to A, right? B and A, like this. So these things should be equal, right? These things should be equal. Which means that cross of B position minus A position and B velocity multiplied by cross product of B velocity and A velocity is equal to cross product of A position minus B position and A velocity multiplied by cross product of A velocity and B velocity, right? Yeah, something like this. And we can see that this multiplication is the same. It's just like this is negative. This so the cross product when you switch the order is becoming negative. So if I divide this, then it means that this is equal to negative this, right? That's the equation that we have. And then since this is the thing, this gives me three equations for three coordinates. Cross product is a vector, right? Cross product is a vector. So this gives me three equations. What is the unknown here? Like one of the A or B's is unknown, right? This gives me three equations and 6 unknown variables, basically. I feel like I'm getting somewhere. B position minus A position is I can just reverse. I can just do a minus here and switch this, which means that I can remove this, right? Is that right? So the cross product of the difference of the positions by one velocity should be equal to the cross product to the other velocity. Right? This is the same thing. Can I like extract it somewhere? I can. Cross product of A position minus B position and B velocity minus this cross product is equal to 0, right? Right. So the next thing to do is to say that so like this is still like the multiplication, and what is this rule, like the associativity? I don't remember, but we can say here that A position minus B position and the cross product of this with B velocity minus A velocity is equal to 0. Here's an even simpler equation now, right? That we have. Here's a even simpler equation. So we don't know one of them, position and velocity. What does it mean like geometrically? So I need to choose two vectors so that the cross product between them. So over here it doesn't matter. It can be A minus B because like plus minus doesn't matter here anymore, right? So the cross product of these vectors minus like around a certain point. Around a certain point, these vectors, they are perpendicular to each other. No, they are parallel to each other. Parallel. This is a cross product, not the dot product. So they are parallel to each other from a given point. So the point is this good? So basically it means yes. So like we start with the hailstone position and hailstone velocity, and then we can change. So if we add something to the position, then we add the same thing to the velocity basically. Or wait, not the same thing, but like we go in the same direction with both our position and our velocity basically. But it does not have to be exactly the same, right? But we go in the same direction. We go in the same direction. Whatever direction we choose. Which means what does it mean? Like I'm almost there, I feel like, right? So we start in our six-dimensional space at a certain point. And the first three, and like the delta from that point, this delta has the first three coordinates proportional to the second three coordinates. So what does it mean? In a two-dimensional space, in a one-dimensional space where our position velocity is two-dimensional, this would give us a line. I think. In a two-dimensional space, I just cannot imagine a four-dimensional is the problem. Ah, shit. Imagination sucks. Cross product. This doesn't give me anything. It's like the same as I already had. I think. Need to add some other stones to constrain the equation. Okay, sure. Let's add another one. Let's add a C here. Sure. Let's add a C. So if A is the unknown one, right? Then we also have another equation exactly like this, but with a C instead of a B, right? I can add another one with a D. Like we have multiple here. Need 3 stones. It makes sense that you need 3 stones because we have, like I said, we have 4 dimensions of freedom. Wait, hold on. Don't we need 4 stones then for that? Well, I mean, every single stone... No, why 3 stones? We have 6 unknowns. This... No, this is still one equation. This is still one equation. With 6 unknowns. Don't I need 6 then? Because, like, technically, I can expand this. Like, a position is basically 3 variables. This is 3 variables. If I take 6, right, then I can just solve the equation by using like some matrix form, right? Six unknowns for position and velocity plus 3 more for time and collision. But time of collision is not unknown if I know the position and velocity. I don't have the time in this equation, as you can see. Raise your hand is JavaScript is the base. I don't see any hands. Yeah. I think this is the way then, right? This gives me this is all the equation that I need for one. So like I can literally say like expand this properly, right? What does it mean for? Oh wait, hold on. The cross product is a vector though, and the vector should be equal to 0 on all the 3 coordinates. Hold on, no. The cross product is a vector, which is 0 on all the 3 coordinates. Which actually this gives me 3 equations. These 3 equations, these 3 equations, which actually means that this already gives me the solution. The 2 things, no? I have 6 unknowns and I have 6 equations because this is basically you know, like this dot x is equal to 0, dot y dot z is equal to 0. And then we just solve this using the matrix stuff, right? For example. And then for the other ones, we just check that the solution that we have found is correct. So a position, a velocity is the only unknowns that we have. Well, let's see. Let's see. No, hold on. Hold on. This is not a linear equation though, right? Because I'm multiplying the position and velocity together. That's where the problems come from. It's because I'm multiplying the position and I'm multiplying the velocity. Here. So it's not a linear equation. I mean, I can say that the velocity is like some formula based on the position and time, but then it will mean that I'm like, yeah, it's like second to the power of 2 is what some of the unknowns are going to be in these equations, right? So I have multiple equations. Where some unknowns are, yeah, it's not a linear equations is the problem, right? Right. How do you solve a set of nonlinear equations? But where the how to solve nonlinear like quadratic, how do you even name this thing? I don't know. Equations with multiple variables. Factoring quadratics with 2 variables, is this it? Quadratic and 2 variables, multivariable quadratic equation. Is this what I want? Yes, this is what I want to solve, something like that. And I have like, so I have like a multiple of these basically. But I have 6 variables, and the maximum power that I have is 2. So we can use this as a quadratic equation in the standard form of Yeah, like I have 6 equations and 6 variables. Though. What are quadratic simultaneous equations? Two and more equations that share variables that are raised to powers up to 2. For example, x squared and y squared. Yes. One key difference of quadratic simultaneous equations is that we expect multiple answers. On the graph below, we can see the straight line of the linear equation has crossed the curved parabola of the quadratic equation and 2 points of intersection. So like we do this, but instead in a 6-dimensional space. Right? Example 1, elimination by substitution. Common misconceptions. Practice. Well, this is not a generic solution though. Solving quadratic equations with many variables. There is a paper about it, a PDF. Multivariate Newton. It's hard to find a good description that doesn't use higher order concepts. I also am thinking about some form of like starting with a random point and then like improving our solution by making things go closer, you know. But like I almost did not think about it. Like, you know, instead of trying to solve it using math, we can try with an approximate. This is what Newton's method is. Do you think I remember Newton's method? I don't know. Newton's method. I don't think I remember it. What is it? Name it after Isaac Newton, root pi, which produces successfully better approximations of the roots or zeroed. Yeah, we take the slope and we like, so like in a multidimensional we would take the gradient or something, right? Is this what it's called? But we don't, we need to know the function. How do we do this in multiple dimensions though? We start with an initial guess, then approximate the function by tangent line. What is the tangent line in a, like in case of 3 dimensions, for example, you can have multiple tangents already, right? It's the gradient. Gradient is what... Yeah, so I need to find the gradient. Hold on, what is the gradient? I don't remember. I kind of remember, but I used it once or something. How approximate can you afford? I don't know. I mean, well, maybe there's some other methods other than the Newtons, though. What is the other? But just follow the gradient. I mean, I know I have the equations. Then I like the gradient is a vector of like df dx and then df dy, and then this for all the things. And this vector is where I need to go, right? And then I go in that direction and see if it's becoming better, right? And how long do we follow the tangent, by the way? This minus current value. Oh, like the gradient gives me like how much is the function changing in all the given directions. So this is just the gradient, and I divide and I take... Wait, hold on. I cannot divide by the gradient, can I? So in the multidimensionals, how do I divide a value? Wait, hold on. What is my actual even function? What is my function? Gradient descent. There's a method, mathematical optimizations. A(n1) minus... so we just do a small step, right? We just do a small step in the direction of a gradient. So the Newton's method like makes pretty big steps, but over here we just do a small enough step, right? Of improving our function, yes, sure. So basically, hold on. Our function is that everything is equal to 0. So for example, I can make a function of all the equations that I have, and like this is a vector, right? So I can take like, I don't know, the I don't know, what's a good function that I would like to optimize here, like the maximum out of all the coordinates of these vectors, because this equation is really simple, right? Yeah, I think we can do like even if I don't know how to calculate the gradient properly using math, I can still calculate the the gradient also like programmatically, right? Like I can change one of the coordinates in my 6-dimensional vector that I'm trying to find by a small enough amount and see how my function changes. So I just need to come up with a function, and my function that I want to optimize is going to be equal to hailstones iterate map. It's a function that's based on an array, on the array of like this is me, you know, me is array, and this gives me a floating point number that I need to optimize and bring to 0, right? So this is a function, like pretty generic thing. I just need all of these equations to be equal to 0. In order for them to be equal to 0, I can do something like equal to 0 means that the length of this is 0, for example, or something else, right? So for every single hailstone, I'm going to say that the cross product of me position minus stone position and me velocity minus stone velocity, right? This thing, I'm going to like take the length of that, for example, and then I'm going to add all of those together to get to one single floating point number. This is array f64. Oh wait, hold on, but hold on. But how can I do this if the advent of code says that I can place at any integer position? I mean, the position that I'm going to find, I'm just going to round it, and that's it, right? But because it is a non-linear, like potentially we can have multiple solutions. So we can start with a random point and multiple times go by the gradient, find the thing, round it up, check that it all is correct, right? Is that a thing? The velocity also needs to be integer, is the thing, right? So I do that. This is my function, right? And I want to find the thing. So let's do a function that is going to be called gradient descent, right? Gradient descent. We have a function which is a function from like n. It's like we're going to make it n-dimensional const usize, right? This is going to give me the solution, right? It's constant usize. I don't use const generics usually. So we have a function from our 6 variables that gives us a floating point number, and we have an origin, which we're going to do like randomly multiple times probably, right? So for this, we're just going to do what? What I'm going to do? I'm going to do a loop. I'm going to have a const. The how did they call it? They call it the learning rate, right? So let's call the learning rate is going to be equal to whatever. Like, I mean, technically, because we want integers, maybe 0.5 is good enough of a learning rate. Maybe. My numbers are pretty big though. I don't know. Maybe my learning rate should be like big and then smaller. No? Shouldn't I do a multiple big steps and then like small steps? Smaller and smaller? Do they use the same learning rate? Is this a constant? Because my position is pretty big, right? Optimally, yes, but you probably don't need it. I mean, yeah, if I like for the velocity, let me show me my input. For the velocity, my numbers are not that big, so I'm assuming that like my velocity of my stone is going to be also about these numbers, but these are great, are very big. Isn't it part of the gradient descent? Choosing the step and descent direction. Since using a step size is too small would slow convergence, and too large would mean overshoot or divergence. Fairly good setting is a good practical problem. Clever choices. Consider direction. General update. Finding good settings requires some thought. Can I not like start big and then go smaller and smaller? What if I do 4 learning rate in 1000, like 100, 10, 1, and 0.1? Can I just do this? And then for every learning rate, I'm going to try and improve like 1000 times, for example. Right? That's questionable. How would you do it then? Like, not like this? Just like, I mean, or I can like, like every single step, I'm going to lower my learning rate by like multiplied by a number. Just pick a small constant. But it cannot be that big. Like, my position is going to be pretty big, you know, is the thing. Did you see my input? Did you see these numbers? I cannot make my step to be 1. It will require 4 like trillion steps. Right? How big will my gradient be? I don't know. well, whatever. Let's say that I have the gradient. Whatever. Let's find the gradient. The gradient is going to be also f64n, right? I'm going to do std array from function I. So position is going to be equal to the original position, right? And then I'm going to say that position at index I is going to be plus equal f. Wait, hold on. I don't know. Yeah, di plus equal learning rate, right? And I'm going to choose to do pf minus f at the like current point. Okay, let's rename this. Let's rename this current guess. So we've fp minus f current guess, and this is how we calculate the gradient, right? This is how we calculate the gradient. So I just add. Wait, hold on. This is not. I'm doing not the gradient. I'm doing not the gradient. Here's what I'm doing. I'm like basically I'm starting with a single point, right? And then I'm seeing if I'm over there. If I'm over there, you know, I'm going to find like where to go, basically. Here's a better idea. Here's a better idea then. Hold on. I know. Let me see this. Here's another algorithm. Is there a name for a thing like this? So we have a function that we don't even know, right? I know a value. I can just know a value of the function here, right? So I'm going to basically in a circle, or like it doesn't even have to be a circle. I'm just going to choose a bunch of random points. Like if we're doing it in a two-dimensional space, right? I'm going to choose a bunch of random points, and I'm going to choose out of these random points, basically the point where the function is the minimal value. All right, and I'm going to go to that point, and then I'm going to make my search space a little smaller. I pick 1 billion random points, 1,000 random points, find the one where the thing is the smallest, and do it like a bunch of times. It's kind of like a binary search, but not exactly. Does it make sense? An algorithm like this? For an unknown function to find its minimum? It's a random search. That's exactly what it is. All right. Does not require the gradient of the problem to be optimized. Algorithm. This is the fitness or cost functions which must be minimized. Position candidate solution in the search space. Initialize with a random position in the search space. Sample a new position from the hypersphere with a given radius. Move to the new position by setting this. But the given radius that they use is what? This is just a constant. I'm proposing that the radius of the hypersphere is also going to become smaller and smaller. So I at least find like the local like minimum or something eventually. More precisely. Covariance. Truly random search is perioded by luck. Sequentially search each parameter with a set of guesses that have a space pattern between initial guess and the boundaries. Fixed step random search. Optimum step size random search. Adaptive step size random search. Attempts to heuristically adapt to the hypersphere radius. Two new candidate solutions are generated with the current nominal step size and one with a larger step size. Yeah, I guess I can adapt it. Optimized relative step size. Optimizing the optimum step size by a simple exponential decrease. Yeah, this is what I thought to do. The simple exponential decrease. You could take the previous step size as the new radius. Previous step size and as the new radius. Let's see. Let's see, radius. Radius is whatever. It's a very big thing though. It's a very big search space though. It's an infinite one. It is an infinite one. But let's start with a radius to be equal to, like, I don't know, whatever. So we basically do a certain number of steps of decreasing the radius. Sure, just a certain number of steps. Sure, just a certain number of steps. But the current guess is the thing that I don't know about. Initial guess. Let's just do like 10,000 times, whatever. I don't know how many times do I want to do it. Right? I just generate the random points. So the next yes is going to be equal. Well, I mean, I guess I need to do like 1,000 times. I find a certain like guesses. It's going to be like another 1,000. It's going to be std iterate from fn. I'm going to take. Is there a repeat with? Repeat with is what I want. Repeater. Yeah, this is what I want. So I just repeat with like repeat with. So I'm going to repeat these values. This is my another guess. Std array from fn based on the index. I'm going to say current best guess is initial guess. Let's do this. So we do current best guess I plus thread RNG. Let's just have the RNG here. Let mute RNG is thread RNG. So RNG generates a range from negative radius to positive radius, right? So this is the guesses that I have done, and the next thing is going to be I take the guesses and I find out of those the minimum by key, and the key is the point, and the minimum by key, and the key where the key is f, right? fp. I guess in order for this to be implemented, this needs an ORD, right? And then I update my current best guess with this. Multiply by a root of radius to get uniform. Uniform circle. It doesn't matter if it's a circle though, does it? I don't think it doesn't matter if it's a circle. How to do uniform circle. I have it in my bad box if I wanted to. It's not hard, but you don't need to do a uniform circle though. You can do a hypersphere, you can do a hypercube, it doesn't matter, right? I'm pretty sure. So this doesn't implement the OR, so I want to do R64 probably, which means that I need to add the num here. Right? And this is going to be unwrapped because we almost always have a thing. So, and then we basically multiply the radius. We multiply it by like a half, for example. If I divide it by 2, it's going to be like small very quickly and don't even need 1,000. I'm just going to repeat with, I'm going to take a certain amount of guesses though here. If I take 1,000 guesses, for example, and I do 1,000 steps, in order to, like, the 1,000 steps, like, it probably needs to be bigger, like 0.95 is probably good enough actually. 0.94, like, I don't know. It just means that the current, like the radius in the end should be like about 0.5, I think, for me to have it work optimally, right? So, and then I return the current best guess, basically, right? It's not a gradient descent, it's called RNG descent. Okay. Okay, so here's what we're going to do, right? I'm going to say that I also can like do less iterations here. Like I can do 100 iterations. Like if I divide by 2 every time, then I can do the number of iterations to be like about 64 for 64 bits that I have in my F64. That's going to be like pretty precise. I think, right? So I can do even less than that. Let's do 50. This is the number of things. Do until the delta is low enough. I mean, yeah, I can do that too. Sure. Let's do basically while radius is more than 0.1 because that's what I want, for example, right? Radius multiply, and then over here I just take the constant. This is a constant. This is the initial constant. This is a constant, and then we basically do. And then we basically want to find where the function is actually equal to 0, right? Right. So just do this, and it should be equal to 0. But I want to round it too, right? Eventually. Okay, so let's do this. I'm going to do loop. I guess this is something that I don't need anymore. I'm just going to do a loop, and I'm going to start with a guess. And the guess I will also always start with array where the position is so like the velocity, I'm always going to start the guess at 0, I think. But for the position, I want to take like, I don't know, the random between the minimum and maximum, maybe something. My hailstones. Maybe let's just take the random hailstone and take its position, you know. Let's do this. Hailstones. Choose. Grad RNG. Unwrap. Just choose a random one and take its position as our initial guess, you know. Let's do this. And then we do the RNG descent. our initial guess is going to be position X, position, no, our guess position X, guess position Y, guess position Z, and guess velocity X, Y, and Z. And the function is equal to actual the f, but this function is from array. So because I did this like that, this is going to be instead, let's do this x, y, z, vx, vy, vz, right? So over here I just call function using array, which has the position of x, y, z, and velocity of vx, vy, and vz, right? So something like this. Consider using a semicolon here, RNG descent. F64 is what we start with. So then we finally arrive with xyz, vx, vy, and vz, with that, right? So here's our our actual, like, this is what we actually get in the end by doing the RNG descent. We're doing vec3 xyz, and we're doing vec3 vx, vy, vz, and then I'm going to round the things to the nearest integer, right? I'm going to round it, and then I'm going to find this value, and if it's equal to 0, let me just try debugging this and see if it gets to 0. Cargo run part day 2 example. So let's see, on the example, it's just running. It does not get close to 0 at all. My RNG descent is not good enough. Let's make this 0.99. My RNG is going up. It's not equal to 0 at all. Right? Well, I can check for the example that at least my function is correct. Hold on. So this is what they wanted me to do. With this velocity. For the example, this function should be equal to 0, right? This function for this should be equal to 0. Right? It is equal to 0. Okay, so we have a 0 for sure. My function is a function. Maybe I can do a better function. I mean, that's pretty simple though. I can do the square length. Is this going to make it better? Probably not. Probably not going to make it better. It's making things a lot worse. Maybe my radius should not be that big. Let's start with a smaller radius, especially for the example, right? 0. Look at this. 0. 0, 0, 0, 0. If I start with a radius of 100. Okay. Exactly 0. Look at that. Let me just try. Let me just try to do it not on the example, but on the actual thing. Can it be so that I can actually find a 0 here? This is probably a little too slow. Let me do the release mode. I think the release mode makes sense. Imagine if it just works here. 6, 9, 4. It's pretty close. 1.2. It's going close. It's going close. What do I need to do? I need to decrease this or increase this? Increase the number of guesses? What do I need to do? This is RNG. Radius more than 0.1. This is good. I'm pretty sure I don't need to make this lower. No, I think maybe the radius should be bigger after all. I should just wait. 1.27. This is a very big number still. 10,000. Should wait for convergence. What do you mean wait for convergence? So like, hold on, just do the guess, like, and find where my function is actually like becoming smaller than my than the function in the current best guess, right? That is important, right? Wait until you stop improving. Oh, until I stop improving. I see. Okay, fine. Okay, fine. So basically, I do a loop. I do a loop here. I'll do a loop here. New best guess. Current best guess is equal to the new best guess. I think the radius gets too small before you actually get to the minimum. Yeah, probably, maybe, I don't know. So we do the loop. And I say that if new best guess, I mean f at the new best guess minus f at the current best guess. This is the improvement that we have, right? The absolute value of that. This is the improvement. I mean, the improvement is actually like this. This minus that. This is the improvement. If the improvement is more, like maybe I should improve by 2 times or something. Divide by 2. If this, then I can break. Is this good? So I improve my current value of a function by 2 times, but that might be a little too much. Might be a little too much. We can do 0. So sure, let's do 0. Let's do 0.5. I get this, or like I'm already close, right? This or already close. So I'm going to take the maximum of this and 0.5 that I already have. Maybe? I don't know. Is this going to help me? 3, 3. Smaller radius, bigger radius. What do I want here? 1.1, 1.0. I mean, while I am when I stop improving, I think when I stop improving, this means that I am still improving a lot, right? This means I'm still improving a lot. This means that I'm stopping to improve. This still is no good. Let me do the initial guess a little better. Maybe I want to do sir, like I cannot do that. Hold on. I want to do std array from fn xyz is going to be from fn. I'm not going to choose. I'm going to take hailstones, iterate map for stone. I take its position at the index I, right? And I find the minimum, or I find the maximum. So I do chords clone min, chords clone max, wrap. This is the thing, minimum and maximum. This thread RNG, generate range over there. So I do vec3 xyz. Let's unwrap. Generate range, this is what we return. Okay, there you go. So we find a random, so like not one of the original hailstones is our thing, but actually in a random place. It doesn't work. Try reducing the radius. The original radius? It's 1000, which is pretty small, I think. Is this the correct here? Look at this. The current best guess minus the new best guess. This is how much I have improved, right? Can you print improvement in each cycle? Well, I'm doing a lot of cycles, I think. Sure, let's make this improvement. Improvement is negative. Well, sometimes it's positive. Well, yeah, it makes sense. I think I want to do this only if radius is less than like 1 at this point. I think improvement is negative, means that if improvement is negative, then I need to like do more searches. I should not move to a worse point, yeah. And this is going to be going infinite now, basically, because of that. Is that right? Just random. Maybe I don't continue, but I only like actually improve. Like I do this only if we have improvement, basically. It's probably the good thing. Are we still working on the example, by the way? On the example, so like you see on the example, I find the 0, and sometimes I find the 80 for some reason. So this is some other local minimum that I even have in the example based on my RNG. It's not even like 50. It's not like I have a. I mean, this is not a lot of samples, obviously, but I'm finding other things than 0. Start with a bigger radius. I don't know. What if I make it faster? By making a bigger radius. No, this is too... Okay, so here we go. I need to improve the number of samples. The number of samples needs to be improved, right? I don't know, maybe. How long is it going to work on the non-example? I'm still 1.69. Nice, but it's not a 0. Okay. I mean, I know my function that I'm trying to do. I could do a proper gradient, I guess, and do the math, right? Instead of doing the RNG. But I don't know. I surrender for today, and I maybe solve it next time. You know, I accept my loss here. You can try solving it yourself, Nerdsel, if you're interested. If you can do it. Advent of code. Anyone else is doing advent of code? I'm the only adventor. Everyone else have solved it already, right? I'm the last one to solve the things. J24 part 2 is insane. That's what I'm trying to... I have been doing it, that stuff for like 3 hours, I think, at least, right? I'm not sure what exactly my time. He was away. Was it a problem finding the line that intersects or the trajectory lines? No. I don't know. I don't know what it is about. I didn't solve it yet. I just decided to stop for today. But I tried to do basically like a gradient search in a function, and the function is like, how close are we to intersecting the things? You know? If my function is how close am I to hit in every headstone. I want to find the function at a minimum where the distance is 0 to all the stones, right? So I try to find a minimum on a function that I don't really like understand much about. So I try to do the RNG search, but I guess something like a gradient search would work better. But maybe it can be solved by just math. I don't know. You also gave up? All right. Yeah. Is everyone given up? Yeah, I guess everyone has given up. I'm the only one who's left. All right. Let's rate someone then. Hard one. It is a hard one, yeah. All right. Pirate Software. Um. Practical NPC.
Yes, show me the code.
Let's go here, whatever.
It's pushing it.
See you guys.
This is fine.
See you guys next time. Which I don't know. Did I investigate a linear programming solution? And for that, I need to know that there is a linear programming solution. I guess there was something about linear programming on the gradient search, gradient descent. This has the linear system, but the problem is my system is not linear, right? Or wait, hold on. Is linear gradient descent can be used to solve a system of linear equations? Yeah. So the problem is my equations are not linear. Is why I had a lot of trouble, you know? I think if my equations were just linear, I would be alright. But hold on, linear programming and linear system is a different. What is linear programming? Is it the same thing? Mathematical models with a linear function is maximized or minimized when they're subjected to the various constraints. Yeah, I guess we don't know the constraints. We actually don't have any constraints. Is the thing. Right? Because we can place our array in any position with any velocity. But anyway, the rate is going to go, so bye.
Into betas.